And we're starting bright and early. Everyone feels okay? How many are super excited to be here? Everyone is, right? Yeah. How many of you are hangover? Be honest. One. That's not true. Everyone else is lying. Tired? Happy? That's good. So, is everyone having a nice day so far? Nice. So we have a bit. We're gonna everyone have to find their seats. So everyone in the venue and in the sponsor area, if you want to find your seats. Is there anyone who has a special day today? Anyone? Who want to confess? No? I heard from a friend that someone is having a very special day today. I'm not sure where that friend is though. I can't really see him. If you're here and you're my special friend, raise your hand. Because I have a spotlight in my face. Let's see. No, I can't see him either. Maybe we should go and check. Can you go and check if you find my friend? Yeah. So yesterday no one died, I heard, which was awesome. Did you like the fire? It was pretty cool, eh? To be honest, they actually dialed it down a bit. Did you notice the lamps? Yeah, one is dead. That's the only thing that I think we lost. No, it was actually pretty cool, eh? And all the heat and stuff. A lot of our the nerd community here were shell shocked. Everyone's like, what's going on? But I think it was really good. It was a good addition. So that was pretty cool. Now let's see. Do we have? Not really. We have to wait a little bit more. A little bit more. It will be worth the wait. We're gonna hear Yossi speak. He will be the opening act. We have to have something very interesting during the morning. Otherwise, people tend to sleep. That's like a thing. Or just watch the stream. So this is pretty cool, because now I think we're getting here, right? Yeah. So I have one thing that I would like to say. Jan, don't hide. Come over here. Come. I want to speak with you a little bit. Everyone, this is Jan. He's one of our sponsors. Give him an applause. He's making this happen. Come up here. And this is a funny thing, because this is Jan's special day. It's his birthday. So I thought that we should do the only right thing, right? And that is to sing for you. So can everyone please help me stand up? And let's do this. I think we should do it in English, right? Otherwise it would be very weird. Okay. Anyone who wants to start this? Okay, so 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear Johanna. Happy birthday to you. Yay! Have a good one. Yeah. Yeah, you may leave now. Thank you, Jan. You had to have that. Anyone else? No. Okay. So without further ado, let's kick day number 2 off with Yossi, who's going to teach us everything about Microsoft Mainframes.
All right. Good morning. Thank you, everybody. The only thing you can say about this conference is that no lamps died while making this conference, sadly. Very happy to be here. Very happy to see all of you in the morning slot, always a challenging one. Maybe not as much as the lunch one, but still. And today I'm going to talk to you quite a bit about HacKtive directory forensics. HacKtive directory in general and forensics. HacKtive directory is a phrase I sort of coined back in RSA like 5 or 6 years ago. when I was part of Javelin Networks, a startup that we sold to Symantec in 2018. I'm essentially a red teamer in mind with the heart of a blue teamer. I really care about blue teamers. And that's what we'll talk about today. So a little bit about myself. I love to play guitars on the world's largest stages. What I really do professionally in parallel to the InfoSec is music and also fly planes. So that's my main passions. But still I do a lot of hours coding and on the computer with my own firm, my own company, 10-Root Cybersecurity in Israel. I've been around with computers for a while. I'm essentially a hacker, a modem kid hacker from the 80s who grew up with the different technologies, OpenVMS, etc., and discovered Microsoft. Got to work for Microsoft for nearly a decade, from the 90s, 98 to 2007. Pretty much the only security guy there. Pretty much the only guy with the Linux machine, with the dual boot in his machine. I sat there when Steve Ballmer called Linux a cancer and I had Linux on my laptop. That was frightening. But other than this adventure, all my life was more of a freelancer, including, like I said, Javelin Networks, me and a bunch of ex-Israeli Air Force officers and intelligence corps, which we developed a deception solution. In memory, unload the driver, creating a really unique deception solution in memory for Microsoft networks. So what we'll talk about? We'll begin with understanding what is Active Directory, why is it so hackable, and why is it that in its third decade, this technology, this identity central management, authentication, authorization, in 95% of all organizations in the world, why is it still so easy to do reconnaissance, lateral movement, credential theft, and essentially privileged persistence in those environments? Then we'll talk about the main part will be how you investigate and build a timeline in terms of forensics and incident response, understanding who did what. When you don't have your logs, all your security logs got wiped, maybe ransomware, most of your domain controllers are encrypted, you only have some backups, quite recent. How do you build all that happened in your network only from this bunch of files? And I'll share with you some open source tools and scripts that I wrote for that. And we'll wrap up. The candy will be a tool I'm working on, quite ready to be released, which detects no agent, nothing through the network, detects pass the hash and golden ticket attacks. So Active Directory is a database, essentially a distributed database, holds all the users, passwords, applications, services, and it is the access control model for Microsoft domain networks. But it's also a technology that, as much as system admins, IT folks love, there is a population that loves it more, and these are attackers, adversaries, hackers. It's really easy, silly easy, to hack your way into an Active Directory domain, and from there to get access, privileged access to any application or service in the network. And even in its third decade, Active Directory continues to be a very highly trending risk in environments. So Gartner keeps on having that every year. Also from this year's top risks, identity first security, nation states are targeting Active Directory with phenomenal success. I love the smell of domain admin in the morning, and me and my team, we have a statistic. Our average is around 7 minutes from normal, non-privileged, not even a local admin user, through a set of dozens of techniques that we use locally and through the network, to reaching a highly privileged user, getting a shell on your domain controller. It's really, it strikes me all the time that even today we find vulnerabilities, CVEs in Active Directory that allow you, like this one, for instance, in late 2020, circa the time of SolarWinds, which also, by the way, SolarWinds also used Active Directory domains as part of its algorithm. This one allowed you zero logon. Probably if you know your Active Directory, you know zero logon allowed you to become from unauthenticated, just having the domain controller IP, to a fully domain admin, fully privileged shell in about 5 seconds. And that was quite a unique one. And this is from recent weeks or months, you know, same account name spoofing. If you can add a computer account, hint, by default, every user can add a computer account. You can become a domain admin. Kerb Relay app, just from last 2-3 weeks, universal no fix, so it really cannot be fixed with the default configuration. And Active Directory vulnerabilities are there in every patch Tuesday by Microsoft, including the last one, just from now, this last May, June. So why is IDEA hackable? So I argue it is a bit like TCP/IP. I think Active Directory, as much as TCP/IP, didn't plan to be that popular. You see, TCP/IP, when it was developed, late 60s, early 70s, it was because of the Cold War between the Russians and America and the States. They needed something to survive. Essentially, the whole thing was availability and disaster recovery to survive like some physical damage, etc. Security was never in the goals or the mindset of TCP/IP to begin with. And this is a bit the same of like Active Directory. Those both technologies got super popular, super common, but they are very far from the threat landscape that they have to deal with. Active Directory was developed, conceived, designed in somewhere in the 90s, mid 90s already the coding happened, so everything was locked in the design. This was before, this was early internet, this was before cloud, of course, before virtualization. Even VMware did not exist back then, not to mention all a bunch of other technologies. And it is involved in every huge breach, and it is the Microsoft mainframe, to say, because it is here to last. I sometimes read some tweets, etc., saying, you know, Azure AD, etc. So Azure AD, by the way, it's a marketing phrase. Azure AD is not really AD. Nothing Kerberos held up about it. And the Microsoft mainframe, Active Directory, is here to stay. Even if some workloads will go to the cloud, on the on-prem, it is by far the centralized identity management solution, here to stay and last for several more decades. And compromising your AD really means game over. I think the problem begins with people having much less in-depth knowledge about AD than they think they have, because it is very popular to say, yeah, sure, I know a bunch of tools, and I downloaded Rubius, Mimikatz, and a bunch of other stuff, and Bloodhound, and this makes me understand how Active Directory works. And I'm mainly saying it also not only for red teamers, but also for blue teamers that think they understand their Active Directory. And I'll give you an example in a minute what I'm talking about. So I think at minimum, before you can actually address some advanced topics such as AD forensics, which we'll discuss now, you should really understand and get a good grasp about how identities, authentication, authorization, and the auditing mechanisms work. Realize that AD can authenticate you not only in Kerberos, obviously NTLM is there, and LDAP or LDAP-S, meaning LDAP over TLS is there. Logons versus authentications, the different logon types, that's really a basic thing to get your head around. Understanding that not only users can log in and authenticate, but also computers. Computers in Active Directory are accounts by all means. They have passwords, they can log in to other computers. Exactly, computers can log in to other computers. And if that's something you're missing, then you can be hacked through computer accounts. And of course, security principles, essentially accounts that, objects that can have a SID, a security identifier, that goes to user computers and groups. And authorization is a tricky thing, because normally people would look mainly on group memberships, like is this user a member of domain admins, enterprise admins, etc., but they will miss out the real thing, which is the access control list. And authorization is all about your token, essentially your access control list, or if we want to be specific in Kerberos, it's the PAC. It's the privileged attribute certificate, which is the collection, cumulative collection of security identifiers in your security token that you present to the network. And you can see where this goes. So you can have direct sys assignment, and you have all kinds of object access types to do different things, like reset passwords, install DS replica, which allows you to add a domain controller. So even if you have 0 other permissions that you will never notice, this very delicate permission is enough to take control of the entire organization. And of course, it doesn't hurt to have some good knowledge of Windows internals. So how processes, threads, handles, security tokens, etc. works, that's a basic thing. Few quick examples about what it means to know your Active Directory. So in this example, we have a user, Laura. And this user, as you can see, is a member of essentially one group, marketing. Domain users is a primary group. It doesn't really count, but So, and also if you will run your default tools coming from Microsoft, so you will get the principal group membership will only contain domain users and marketing, right? And many admins will work by the assumptions that that's what this user can do. Anything that you granted to this user specifically or to the marketing group. But as you would see, this quick parser script I provided for you. So when you will run this script, which essentially enumerates the privileged attribute certificate, so this, by the way, you can do for any user in the domain. So you will see you got 4 groups back: marketing, managers, and development. Where did those groups come from? They weren't in the GUI. They are not in my other management tools. And what you would see if you will dive a bit more closely, and you will consider perhaps the concept of nested group membership. So you will see that the effective group membership really also includes groups that you are part of up there in the hierarchy. So this really means that some permissions that are granted to other groups that this user does not have directly can affect the de facto access permissions that this user will get. Another interesting case is the case of admin SD holder. So the administrative security descriptor holder is essentially a container in Active Directory in your domain. And if you look at this user, in this example here, a user called Kai, so this user does not have any group membership, right? So it just has the primary group, domain user, very simple one, doesn't grant you any specific special privileges. Of course, he cannot access the C$ drive of a domain controller. That's not something he would be able to do. So for your average blue teamer, this user is essentially not a risk, is useless. You know, he can't do anything. But watch out what I can do with this user. I can go ahead and look at enterprise admins, non-arguably one of the most privileged groups in an Active Directory domain in a Kerberos realm. And this group gives you forest-wide permissions. So in a way, it's a bit even more privileged than a domain admin. And I can go ahead and add other users. So I just went ahead and added Ashley, some other user. How can I do that? Is it even possible, given you saw my group membership? So I don't have it in my SIDs. There is no direct SID assignment that allows me to do that. And still I am able to do that. So just think about that. And understand that Active Directory has a set of permissions per object, per property, read-write at the property level, and you should really be aware of that. I love this quote from Ernest Hemingway: the best way to find out if you can trust somebody is to trust them. And oh boy, does Active Directory trust any authenticated user or computer. You see, I guess back in the 90s, it didn't matter much that after you got authenticated, you proved your claim that you are this and that user, then you could, for example, do full reconnaissance, dump the entire DNS zones of your domain, get all the privileged users, where are they logged on from which IP addresses, what was the last time they changed their passwords, what was the last logon of each and every user, and from which IP it happened. So all this information, essentially with some code, you can get all this information freely. And the second point is that not only this information is available with full reconnaissance of your assets to every user, it is also available in a bunch of dozens protocols and APIs. So LDAP, DNS, Kerberos, WMI, RPC, DCOM, OLADB, ADSI, System Directory Services, ADWS, AD Web Services. These are all just a tiny bit of APIs and protocols you can access Active Directory to query for this information. So there is no surprise that it is a part of any advanced persistent threat, any big APT by nation states, and you can also see it in every ransomware that respects itself. And just have a look at the ports on your Active Directory. Obviously, web services were not invented back then, and nobody thought you could or would want to tunnel something on a single port one way, God forbid. So the ones on the yellow are the sort of mandatory ones that you would expect to see. The blue is also mandatory, but not from every endpoint on the network, but you need it to manage Active Directory from your PowerShell AD module. And the last ones, of course, are also very important. You can maybe minimize this range of ephemeral ports, the high-range ports, up from 49152 to 65535, but still you need them. As if this is not enough, Microsoft kept us confused all the time, us architects, blue teamers, sysadmins, etc. They had a chance to change their mind about what is the best practice architecture, security architecture for AD. In roughly 20 years, they changed it like 5, almost 6 times. So back in the 90s, in the NT4 good old days, the message was the more domains, the merrier. They didn't convey this message because they thought it is good for you to distribute your domains, just because they had a hard-coded limit in their SAM database. Not many are aware. It helps to work inside Microsoft to see it in the code, that there is a hard-coded limit of 40,000 objects that this SAM account database, security account management database, could go to. So they didn't want customers to get a denial of service on creating new objects. But then came NT5, today is known as Windows 2000, and that was the opportunity to consolidate domains. So they pushed all the customers to get all the domains into a single domain. So many geographical domains became headquarters, just one domain. But then they realized, quite a lot due to folks like me and others, that we said, guys, every inside a forest, inside a domain is not a security boundary, it's an administrative boundary. You maybe can manage your policies, password policies, but all domains in the same forests share transitive Kerberos trusts. That's how Kerberos, MIT version 5 Kerberos in Linux, Mac, etc. works. So now that Microsoft adopted it, it was not really sure how Kerberos worked. So in a way, they implemented a mature authentication protocol with a lot of other vulnerabilities, but still without understanding how it works. And then trusts are bad as well, seed filtering, seed history, etc. Then came the Red Forest model, which was very hard to implement and very costly, and it doesn't play a lot along with cloud these days. Admin tier model survived quite a lot, quite some years, and now they're speaking about privileged access. So imagine customers having to change every 2-3 years their entire architecture of their directory services. That's obviously not something that you can do, and that's how we hack organizations. We just use the bad architecture that they implemented like 10 or 15 years ago, and they didn't move from that. That's how easy we go from DMZ to internal network, etc. And of course, to add on top of it, we have the users. Users as the weak link in this chain. You can give them amazing features. You know, no NTLM, you don't get your password in LSAS, just enough administration, which is a constrained, delegated sort of Windows SSH built in, and they don't use it. They prefer to use RDP. They prefer to use to cache their TGTs, their ticket granting ticket everywhere, and just go over it. So now handing over to forensics. So how do you get your hints about understanding what happened in your domain when your domain was hit pretty bad? And I saw it in dozens of incident response cases in the field. And unlike Goldilocks, you know, attackers don't leave you deliberately hints, you know, in your bed and in the soup they drank or the chairs. You just have to grab those by yourself. So in Active Directory forensics, we realized that we're facing a centralized identity management authentication authorization system, which by design has a set of misconfigurations, excessive permissions that we have to deal with. But we still want to build a timeline, who did what and when, and understand the entire reconnaissance, credential theft, group membership changes. And the sources of truth really boil down to like 3 areas. One is a bunch of files. Sysvol is one of the more known one, holding not only the group policy settings, but also other files, logon scripts, etc. The ETW, event tracing for Windows, essentially the event logs of the Windows operating systems, and there's a bunch of them. And pure packet capturing, right? So if you would prepare in advance and you would run sort of pickup on your domain controllers, you can either respond in real time to some specific patterns in your pickup, or you can, in retrospect, pick up the pieces, pick up the pickup, and you can get those pieces. But there are 2 files that I encourage you to look more deep into, and those are the NTDS DIT, essentially the NT, New Technology Directory Services Directory Information Tree. That's the database file of Active Directory, and a property that exists on each and every object in the domain, which is REPL property metadata. And we're going to speak about those 2. So NTDS DIT is it is the AD database based on a JetBlue database, extensible storage engine, just like Wins, Exchange, and some other applications. It comes with a bunch of other files, log files, checkpoint file, etc. And it is managed by a bunch of tools. The most notably one is NTDS util, a command line interface tool that essentially can get snapshots from that database, repair it, do defragmentation, etc. So the database file, unlike, it's not a relational database, right? It's essentially a flat file. It works with pages internally. And these entries that you have there, you can actually access them and see them through a bunch of APIs. If you want to begin to code to that, so I encourage you to begin with ESE NTDLL, or if you're already into some known frameworks, so you have DS internals, which is essentially C# wrap that you can also utilize through PowerShell and stuff like that. But it all boils down to the NTDSA, the Directory Service Agent, which exposes the database through several APIs that you can query. The thing you have to really pay attention to is the database state the database file that you picked up. Because you will see here, for example, I have two different databases from two different organizations, different everything. And the first thing would be to run escntutil/mage on the dit file and just get a dump and some statistics on the header, the checksum, and the state of the database. Was it shut down clearly in a clean state or a dirty shutdown? Because if you will have a non-clean shutdown on the database, it will be very hard to perform many actions. You have to recover pages with a hex editor, and that's not fun. But here you can see I have a very consistent database file. This file is obtained by backups, by taking a snapshot in NTDS util, etc. But let's say you took a snapshot of the database using, for example, volume shadow copies, VSS admin, etc. Many times, if you took this type of snapshot, which would happen during an incident response, so the database you will get will look something like this. It will be in a dirty shutdown state, and you can see that the logs were not fully committed. The last consistent log is like 5 pages difference, 5 transactions different. And what does this mean? The way that Active Directory database works is that changes are written to memory, into your domain controller RAM, and then they are written to the disk cache, if there is a disk cache in some disk, not SSD. And then it's written to a log file, and then the log file, when it feels it's ready, writes it to the NTDS DIT, and then the file is consistent. So while this can happen in a matter of milliseconds, still this can create you a dirty shutdown NTDS DIT file. And speaking about REPL property metadata, so this attribute, essentially, as you can see, it's just a hex decimal. It's just a bunch of bytes on an attribute on each and every object in Active Directory. But it is also represented logically in two different properties, MSDS replication attribute metadata and MSDS replication value metadata as a multi-valued attribute for multi-valued objects. For example, group membership is a multi-valued attribute. And how do I see where in the DIT is this MSDS REPL whatever? So you can see that in this case, you don't find this attribute. It's like Yossi is making it up. You know, you also won't find it in MSDN either. But if I look, essentially, if I pick up the specific property, REPL property metadata, so you see I get back a bunch of bytes, right? So something is really there. It's just not, by default, it's not showing on the object. It's not exposed on the properties by the object that is getting returned. But I promise you that if you specifically ask for this attribute without knowing that it exists, voila, we get back an XML. And keep in mind that when Active Directory was conceived, JSON did not exist, so don't cry because you have to parse XML. But wouldn't it be nice that nobody would have to convert bytes or parse XMLs? Wouldn't it be nice if you had a command line that just parses it all to a grid, and you can filter that grid and see all the changes that happened in your domain? Well, that's exactly what I did. So in this scenario, we're going to search for strings in AD objects, just do a quick scenario, find some renamed accounts that allows us to understand that some user has been renamed since the malicious actions happened with that user, only to discover all logs were wiped, we don't have any logs to work with, and then AD replication metadata will come to the rescue. So first things first, we got some evidence that a user named Annette did some malicious stuff. So we want to get the user, and oops, we don't even find this user under the domain we're working at. Interesting. Maybe it got deleted. So keep in mind that in order to have a recycle bin sort of feature in Active Directory, you have to enable it. It's an optional feature and not enabled by default. That if you want to reanimate or recover objects, so that's something you have to do it in advance. So that's a prior to the incident. But one of the scripts here is a script that finds strings in AD objects. It just goes recursively on all the properties of all the objects in the entire AD structure, and it just finds some matches. In this case, I looked for some Beverly Hills address, but I found just this time format, file time format of on some attributes of password last change attributes. And if I look for a certain string, for example, password, I found a bunch of stuff. All the password replication isn't interesting, really. But at the end, maybe you could see there, we had an evidence that a password reset happened by this user, Annette, at some point in June 2021. So a user named Annette did exist in our environment, so we know that. So maybe it's time to look for possibly this account got renamed at some point. If it didn't get deleted and it is still there, so we will find it by looking for renamed accounts. So that's the next command we're going to run. We're going to look for whatever is remained from our logs, and maybe we still have the set for a renamed account. So we see two renamed actions, event 4781. One is not relevant to our case, and the other is very relevant. We see that it was renamed by some administrative account from Annette to Jane D. And this Jane Doe is essentially the user that did the actions, only it's now under a different name, right? So we have this, this event. I'll just go a bit more into this here. Okay, so the next tool we want to run is essentially looking into the replication metadata history and popping it up to a grid. And this quick script, you can just give it a bunch of accounts, computers or users, and it will give you all the changes that happened since they were the beginning of your Active Directory. And you don't need any logs for that, just the database file. You can also do it offline. The script supports offline and offline online modes. You can see it was created in 2016, this user Jane D. You can see when it got renamed. You can see the that at some point in 2020, it became an administrative, a privileged account, because it got the admin count bit flipped to 1. Essentially, this happens when you are added to one of the known privileged groups, backup operators, server operators, account operators, enterprise admins, etc. And another thing interesting that happened, last change, was it got the seed history populated with a relative ID of 500, meaning that it has a seed history populated with an administrator account from a different domain. This is really not usual. That's something that you should really pay attention when you see that in your AD forensics. So the next script we're gonna launch is get AD group changes. And what this does is allows us to look for group changes in any scope since the dawn of your domain controllers. Again, either online or offline. Now I'm using it online versus the domain controller that is still on. And you can see here the actual change date and the group that belonged to when it was, the last change was it was removed from backup operators at this time. So this is the time added and removed. So you can see for 2 minutes, right? For 2 minutes, this account was a member of backup operators and then removed. Backup operators essentially is local administrator on domain controllers. This means it can do a lot, quite get you to domain game over. We can also pop up changes for specific groups, obviously. These are all the group membership changes since the dawn of the domain to the domain admins group. And again, I don't need logs. Even if now I come to a domain of a customer that is running Active Directory for more than 20 years and he has no SIM, he didn't do any syslog forwarding, I can still get this data from parsing the raw database file because it is kept in the replication metadata inside this flat file. You just have to know to parse it. And so you see here the changes for this user. And lastly, the thing I want to show you is that this also works in an offline environment. So up till now, everything I've shown you here was on a live domain controller. You can see my AD service interface is responding to a live domain controller. But now I'm flipping over to a workstation that is not connected to a domain, obviously. But also here, I can run this command, get AD group changes, but this time I'm going to use an offline backup, essentially a snapshot taken with NTDS util of the Active Directory database. Note that you don't need any other file except maybe the log files if you're in a dirty shutdown state. But you don't need the system hive. For this, the registry system key you only need if you want to grab NTLM hashes, passwords from that file. So you need the decryption key. But then let's run it now offline. So we're going to use an offline database backup and just point it in the NTDS database dit file, right? And we're going to ask for the user Adam. What this will do, essentially, it will load up. It is an LDAP server, as to say. It will load up the database in memory through some random available high port. And now this instance is loaded on your normal machine or your endpoint, and you can get the information, all the changes, also the replication metadata, all the changes. In this case, I'm showing you the group membership changes. Those are two different scripts that work with the same mechanism of locally loading an LDAP server, exposing you the entire DIT file in memory. And obviously, you can also use one of the fun options is just generate a full report of all groups to a CSV file or to a grid. And this will just dump all the changes that happened in your domain since it was installed into a nice grid that you can search into. And of course, show you when the change was made, and if it's an administrative user, it also gets this bit of information from the database, etc. And here you can filter by anything you want. That was the forensic part. So now, us hackers, red teamers, we keep on searching for this ticket of gold. I don't know whether you are a Neil Young fan or not. The curb TGT hash is something that we are looking for quite extensively. And obviously, even if you don't know much about Active Directory, you probably heard about golden ticket attacks. Golden ticket essentially means game over for the organization. It is relying on obtaining, that the attacker obtains the curb TGT, essentially the master password, the main symmetric key responsible of integrity of all ticket operations, authentication and authorization in Active Directory. And compromising this hash, whether in NTLM, RC4 or AES formats, means game over because you can do offline authentication tokens forging, offline TGT forging, and then you effectively get privileged access persistence. So this curb TGT hash can be obtained in several ways. Obviously not trivial ones, but to a seasoned attacker, they are quite trivial. You can get it through any unauthorized Active Directory application interface. DC Sync and DC Shadow are the known ones, not the only ones. But this really relies on a specific delicate object access permission type called replicate changes all. The other one is obtaining a copy of your AD database, the customer AD database, or a backup. You would be surprised in how many engagements we got a copy of that file from a hidden dollar share of some old backup files that IT thought nobody will see, but obviously you can easily enumerate SMB shares in a Microsoft environment in read-only access, so everyone read aloud, read permission. But you can also, it is already a game over move, but the third option is to steal it directly from the domain controller memory. So obviously, if you're on the DC, any read-write domain controller will give you the curb TGT hash, read-only domain controllers, unfortunately for an attacker and fortunately for blue teamers, they don't hold the same curve TGT value. They have different curve TGT users with different hashes. And the attack can really be utilized and exercised with a set of parameters and tools. Most notoriously known is obviously Mimikatz, with you can do it with a bunch of different hashes. You can also create it to walk like a duck, look like a duck, etc. So today I'm announcing a tool called Goldfinger, which is essentially a script. It's a PowerShell script, which is PowerShell is probably the best thing that happened to Microsoft. I was beginning to give up on that company, and then they came up with PowerShell, which is you know, the closest you can get to feeling like you're in a normal CLI environment. It works with, it's like, for me, PowerShell, it's like if Python, Perl, shell scripts, Bash, and all went into and .NET went to a motel room. Whatever happened, this blue shell came up running the other day. That's what happened. So it has everything you would expect, all the greps and awks that you can pipe in and out, and it's also based on objects. So it's the power of objects and the easiness of Bash-like commands. LSPS, everything goes. So it's a PowerShell script. Unfortunately, I wasn't able to finalize it for Security Fest, but it should be ready. I have a bunch of other last-minute checks to fix. But it will detect pass the hash and golden ticket in real time. No agent, no dependencies, no modules. It works with either WinRM, a partial remoting, essentially web services management, or SMB, utilizing the non-commercial PA exec tool. The research really handled a bunch of anomalies to cover all types of suspicious TGTs, suspicious authentication tickets. It supports running as different domains, supports running the entire domain or specific computers. You can also optionally enable WinRM if you want to, especially if you're in a live incident. This can be very helpful because by default, WinRM as a service, a protocol, is not enabled on endpoints, on workstations, only on servers from Windows 2008 R2 and above. I also go ahead and fix some clock skew issues that will give you RPC not available errors. This sometimes happens when the clocks between the endpoint and domain controller gets skew over 5 minutes. So I fix that and then I get the data and much more. So it analyzes the tickets, finds the anomalies. And hopefully it will be ready for Hack in Paris. That's the next convention I'm speaking at later this month. And just a quick preview, a quick demonstration. So in this environment, I have on this machine 3 virtual machines, domain controller and other 2 workstations. First off, I'm gonna just run the script with the default options. No parameters given. And as you can see, it ran using the default collection methods of WinRM. It found 3 potential computers. 2 of them responded through WinRM. No suspicious entries found, but it did collect 10 Kerberos tickets, and it did save them to CSV. So we're just gonna have a quick look at that CSV and pop it to a grid. And as you can see, so it is essentially, even before the detection, it does, as a free open source tool, doing something that many commercial products fail to do until today. It is also essentially a TGT collector. So you can collect all your authentication, active authentication sessions, Kerberos sessions in your domain and just parse them or look through them, even on a daily thing, even if you're not under fire and under stress. So let's go ahead and do something nice. Let's go and hunt for a pass the hash session. And for that, I'm going to switch over to another VM. This would be the Windows 10 VM. Here I'm logged on as a user named Adam. And Adam prepared in advance the anti-LM hash of an administrative user, of SID 500 administrative user. And it's going to just run Mimikatz with pass the hash. So many of you obviously know this secure LSA by Benjamin Delphi in Mimikatz. And what is pass the hash? It's essentially an impersonation token that has a different anti-LM hash than the primary token of the process, right? This is the definition. So my primary token is Adam, but the impersonation token, as you can see, the K-list, the Kerberos tickets, I'm coming out to the network as user administrator. this is how pass the hash looks like on the endpoint itself, the compromised endpoint. And of course, you can go and look for and parse events, collect events from the domain, etc. But this is very easier and quicker. So as you can see now, I ran the tool again, and the whole tree lit up. So I found a suspicious ticket. You can also see it in the CLI in the back, but it also opens up in the grid. You see there is a potential pass the hash ticket, suspicious ticket, and you can see the machine it's on, and here you can respond, right? Now you can do some remediation, isolate this machine, whatever you want, and it also keeps a separate report of all the TGTs, but also a separate report for the ones that matched the anomalous suspicious tickets. Now we're gonna create a golden ticket, also by using Mimikatz. We're gonna go back to that same machine, and we're gonna run it, but this time with a different syntax, the golden ticket syntax, which we prepared. And in this case, this really means we're gonna use the curb TGT hash, the NTLM hash, and run it. This type of syntax you will see in many articles. That's very common for, and we're gonna use the PTT option, essentially pass the ticket. So we injected, as you can see in Klist, we have the administrator ticket in memory injected to this session. And now when we run again the tool, this time we're gonna run it with the parameters. We're gonna run it with the different collection methods using SMB. SMB is a bit slower because it works with the admin dollar share, same as PSExec, right? And it has to copy over some files to the temp directory. But now it got us back two suspicious tickets. Obviously, the first one is the one we still have on that machine from previous pass the hash attempt, and the other is the golden ticket. You can see the list of anomalies it found on the golden ticket, right? So everything is wrong. The encoded ticket size, the session session name is not matching the client name. The time difference, the default of Mimikatz is creating for persistence, creating a TGT not for 10 hours, the default, they work in Kerberos, but to create it for 10 years. And now for the last thing, we're gonna create a really stealthy, advanced golden ticket. This means we're gonna walk like a duck, look like a duck, behave like a duck. So this is the closest you get to fooling some network anomalies, pickups, etc. Even if you collect them through the network with some Wireshark or whatever. And let's go ahead and do that. So we have our special syntax on another machine. I switched now to a different machine, different VM, Windows 8 -PC. And on this machine, I'm gonna run the more advanced syntax of this command. And in this machine, I'm running with a different user, but also a normal user. Now I'm gonna run it with these specific options that mess around with the time, beginning, end, and renew. So this will be a ticket that impersonates a real ticket that was given to you by a domain controller with all the rules of the domain you're living at. So we're really making some efforts running the parameters to make this look very normal, right? For an offline forged TGT. But even in this case, when we run again the script, we can play with a bunch of other options just to show you that there are other options. But we run it on workstations only and some verbose that will give us some, and some logging level. Okay, so we're going to also do some extra logging. And as you can see, it found this third suspicious ticket. Now we have two distinct workstations in the red in the back there. That have anomalous tickets, and the second ticket in the list on the Windows 8-PC machine, you can see it has a logon server, everything's great, it has an AS256-bit encryption key, it has a time difference of 10 and all, everything looks okay, but still the session name could never match the client name on the Kerberos and have an integrity level of the ticket, because you cannot have the primary token and the impersonation token and the Kerberos ticket at the same time. And of course, there is the log, so you get to see how it ran. So all those bunch of tools and scripts, they are ready for you. You can either pick them up from my GitHub page or from hacktivedirectory.com, and I'll keep on editing this. So to wrap up, obviously, I gave you a chance to see there are many forensic artifacts that you can get which are very far from being out of the box, but if you pay attention to them in advance, you can really grab them with the right knowledge and open source tools. Keep in mind that HacKtive Directory Forensics is a part of a wider picture, right? There are signals coming from the endpoints and some logs in other places in the network and firewall logs, etc. So adopting an event correlation sort of threat hunting mindset, XDRs, etc., can really help to search for high fidelity alerts rather than false positives. I encourage you to practice a before, during, and after approach, meaning essentially before, during, and after an incident. Before an incident, turn on the events that you want, run those tools, get familiar with them. During, of course, you can use them. And in a post-IR, you can understand what are the changes, even if you are missing a lot of information and files. And do check out the pages and the scripts, use them, give me comments, tell me what can be improved. And hopefully that the last tool I showed you, Goldfinger, should be ready by Hack in Paris this month. So thank you very much. We have time for questions?
Yeah, we have time for some questions. I'm
okay.
Sure there are some questions, right? Anyone? Good.
Yeah. The question was, why is this random guy from Israel provided a script that detects this anomalous tickets, and why is Microsoft not doing it for the last 30 years? I phrased your question with your permission. The question is, I would assume because this doesn't bring Microsoft money.
Fair enough.
You know, to be honest, if you buy licenses, E5, whatever, Azure, and you put everything in the cloud, you are signing up to the biggest, you know, vendor lockdown in history, obviously. But, you know, there are reasons to do that. It's not all black and white in the world. I respect that. But yeah, to be honest, I think it's just not in the mindset to provide free tools of an on-prem technology that customers already bought. So you already pay for that. They want to build tools that are for things that you pay in the future. I'm sorry to be blunt, but I think that's the answer. I don't think they lack the knowledge to do what I do, which is essentially pop up a system shell, losing multiple protocols, and from this system shell enumerate Kerberos sessions, dump them, parse them, analyze them, and do some research to see the anomalies in the different fields of the tickets. It's not rocket science, right? Flying planes is, it's also not hard when you get used to it, but it's harder than writing the script, probably, on the time it takes.
Anyone else? Some additional questions? Come on, don't be shy.
Don't be shy.
It's always that in the first talk of the morning. It's like everyone has to sort of get in the mode to actually dare to say something. Anyone else?
Yeah, sure. Hi. Come again, is it if they are false positive in what?
So do your script find false positives?
Yeah.
Does it happen?
Yeah, that's a good question. Actually, there are cases where you would get false positives. That's why the script is not yet released, because I'm adding an exclusion. Some features I want to add some more arguments to the script is to exclude certain machines. For example, if you run it against an SCCM machine, you will get a lot of false positive past the hash, because Manage Engine, SCCM, Exchange, those type of machines, they actually perform past the hash internally. They pop up shells that are impersonating other users, and the primary token is different than the impersonation token. So I want to give you those options in the tool and minimize false positive as much as possible. But to be honest, if you just run it on all your workstations, endpoints, the chances for false positives are very, very rare. It will mainly happen in certain task-specific servers in an average AD domain. But I still want to give you this option. That's why I'm not releasing it yet. So I want to be as customer ready when it is out. But it's a very good question.
Yep.
Yep.
Is this tool something that you could picture a red teamer or an attacker using, or is that sort of a chicken egg question because you have to already own the entire domain to be able to use the tool effectively?
Right. So the question is this a tool that red teamers could also use, or is it like a chicken and an egg question, like you need already the permissions in order to enumerate the Kerberos tickets from each and every endpoint? So it is true. Essentially, every admin tool is an attack tool, right? It all changes in the concept, in the context that it is ran. It's like any other tool, like a knife. You could prepare salad, you can stab someone. So you can stab someone with the scripts, and obviously use it for reconnaissance, but you would need the permissions first. So obviously you need this script to run with a privileged account that is essentially a local admin on the endpoints, because you need to enumerate all the Kerberos sessions from all the logon sessions on that machine. So in order to do that, you need a token as a system account. And if you already have this permission, you can do a bunch of other things. So running this script as an attacker is less frightening or less worrying, but running it as a blue teamer, that has a lot of value. One of the options is to add also a lapse support, but I'm not sure this will be ready by the end of the month, but I will do my best.
You have
Yeah.
one more over there first.
Which one? Sorry.
Ah, same question. Nice
okay.
save. Yep.
Same chicken and egg question. Thank you.
Go ahead.
Right. So you're relating to the last tool, the tickets, the detection, suspicious ticket one. Right. So the question is, if my tool is collecting some information from the KDC, essentially, is it grabbing some settings from the domain controller? The only setting I'm taking from the domain controller, essentially in a simple LDAP query or grabbing it from the sysvol, is the password, the Kerberos policy of the domain, to know what is the default time for TGT renewal and how long will be renewed, like the default 10 hours, 7 days. That's the only thing I pick up from the domain controller. The script runs only on the endpoints. So I really don't need anything from the domain controller on the suspicious tickets detection. On the forensic side of scripts, the replication metadata, all history, and get AD group changes, all those parts of demonstration that we had in the middle, those require either an online active domain controller, any domain controller, and or either an offline copy, backup of the database, just the database, no special permissions. So for an attacker, coming back to Dan's question here, that would actually be quite useful, because I'm just using a normal user with LDAP queries. So anyone can grab this information. Remember, trust is a slippery thing.
Nice. I think
Nice.
we have to break there because we.
Yeah, we have to.
Yeah. So
Anyway, I'll be available later.
Yeah.
I'll be here throughout the day.
don't be shy.
Yeah, don't be shy. Yeah.
So hand of applause again.
Thank you. Thank you very much.
Yossi. And before we jump to the clouds with Maithri and Krishnaa, right? Yeah. I think everyone deserves a little bit of water and coffee. So we will start in 15 minutes. So if you want to grab a quick coffee and maybe some Everyone in the sponsor area, find your seats. They're very slow. Run, charge. Yeah, so we will begin in 2 minutes. Find your seats, please. A warm applause to Maithri and Krishnaa. Almost right? Yep. So now we're gonna visit the clouds.
Thank you so much. Good morning, all. I am Maithri Nadig here. I have Krishnaa Srinivasa, my co-presenter, along with me on this podium. So today we will be talking about exploitation and automated detection of threats present in our modern cloud infrastructure. A brief introduction to ourselves. Krishna and I are just a bunch of students. We are bacheloring in computer science. Along with our co-author, Mahima, we are interning at a company called Deep Armor. It is a security consulting firm which is making some noise, and we also won one of the most scalable startup recently. For today's agenda, we will be looking in an overview about web application security and cloud infrastructure security. We will also look into the different standards that are there and why we will be going above and beyond certain industry standards. We will also demonstrate few practical attacks for more understanding. Finally, we'll be wrapping up our presentation by looking into our proof of concept for today and the solution for this. So we all know that web application security is the center for any web-based organization. That means you need to secure your web application by securing your APIs, portals, consoles, the cloud infrastructure, and many more. So all of these can be majorly divided into 3 sections. One, the console, portals, web pages. The second is the APIs, and the third being the cloud infrastructure. So the first two sections are majorly taken care by the developers using a security development lifecycle and the CI/CD for Scrum. The third, cloud infrastructure requires you to continuously monitor your cloud infra. Usually, developers tend to forget or neglect this, thinking that your cloud service providers are responsible for it. We'll get back to it in a while. Focusing on web application security, we have a 5-step approach for this, that is from S1 to S5, and we recommend you to start it in the earlier stages of your web application development. That is, as soon as your program POR has been initiated, till the deployment and the maintenance part of it. So the S1 that looks into your security architecture, key security attributes, and the security objectives is done usually during the program POR stage. The second, or the step 2, looks into the attack trees that is done during the design phase of your web application. The third is the looks into your focus security code review that is done usually during the implementation phase of your web application. The fourth step looks into fuzzing and pen testing. That is during the pre-launch phase of your web application, and it also gives you a vulnerability report on where you should be focusing your efforts on. The fifth, or the final step, looks into incident response planning. That is during the maintenance or the deployment stage of your web application. So this is our 5-step approach. Along with this, we also have an additional step that is called as CI/CD for Scrum that majorly focuses your efforts on any new feature that you can add it on to your web application. Along with these, we also look into certain industry standards such as OWASP, SANS, and NIST. Now, let's look into cloud infrastructure security. I would like Krishnaa to take over from here.
Hi, guys. So, cloud infrastructure security basically is securing all your resources and your services that are deployed into your cloud platform. So, the essentials that are required in your security perspective is to provide data encryption. So, the data should be encrypted in rest as well as when it's in transit. We should also provide high availability. So, any resource should be or the services should be available at any point of time. We should also provide with strong authentication by allowing the users to by giving the users only the certain permissions and providing with strong password policies and multi-factor authentications. We should provide customer isolation so the customer's virtual machine cannot be accessed in the private network found. And we can use hybrid cloud as it provides the scalability of the public cloud while the control that the private cloud offers. By having these essentials in your cloud infrastructure, it is easy to securely configure and monitor your cloud platform and provide threat intelligence as well as forensics if any vulnerabilities are found. So when we talk about cloud security, the shared responsibility model comes into picture. It's a security framework that's followed by many cloud platforms like Amazon Web Service, Microsoft Azure, Google Cloud Platform, and other such cloud platforms. So the framework basically states that it's not just the cloud service providers' responsibility to secure the cloud, it's also the customer's responsibility to make sure all your resources and your data is secured in your cloud. So the Amazon Web Service is mainly used and widely used across the globe, and it's also provides more services compared to other cloud platforms. Therefore, we'll be using AWS, that's your Amazon Web Service, as our proof of concept for this research as well as our presentation. So the shared responsibility for AWS has been divided into two parts. That's your security in the cloud and security of the cloud. So security of the cloud is provided by the cloud service provider, here your AWS. So it provides security to your infrastructure, your hardware, your software, your networking. So the AWS makes sure all your services like your S3 or RDS are secure. The second part is the security in the cloud. That's the customer's responsibility. So the customer has to make sure they securely configure the data that they're going to add into these resources. So they have to configure specified permissions for your IAM users, provide strong passwords and multi-factor authentication. When it comes to data, they should configure that your data is always encrypted and not publicly accessible. If we take one example for the shared responsibility model in AWS, so if a customer wants their RDS, that's their relational database service, to be only connected to one VPC, your virtual private cloud, so the customer should configure this, and the cloud service provider will make sure that this RDS is always connected to only that particular VPC. So when we speak about security, there have been a lot of cases that have come up in the headlines about cloud security attacks. Few of them are stated above. So it is found out that almost Facebook lost 540 million records. This has happened because their S3 buckets were made public. It is also seen that whenever there's a cloud breach happening, almost 15 million US dollars have been lost. There's one particular case that created a lot of buzz and that especially piqued our interest. It's of the Capital One's data breach. It is found to have been the biggest data breach till date, and so a hacker gained access to the bank servers of the Capital One, and he was able to compromise almost 100 million clients' user accounts and their credit card details. So we'll talk about this particular case in the next slides. As we saw that a lot of money as well as data is being compromised because your cloud is not secure, we must find ways to mitigate these kind of attacks. So the community has come up with a few standards like your CSA, that's your Cloud Security Alliance, your ISO 27017, and also CIS, that's your Center for Internet Security. So we primarily use CIS, that's the Center for Internet Security, in our POC. So CIS is a non-profit entity that provides us with best practice solutions against any kind of cyber attacks. So CIS provides us with benchmarks that are the recommendations. So these recommendations are the baseline configurations on how to secure your system. So the benchmarks have been divided into 3 sections by CIS. That's your level 1, level 2, and your STIG. So the level 1 is your base recommendations or the basic requirements that are needed to securely configure one system. The second level is your defense in depth. So these are recommendations for organizations where security is a paramount. So if compromise of security happens here, there will lead to a lot of adverse effects in your organization. The third level is the STIG level. It's basically the overlap of the both level 1 and the level 2. So we've primarily chosen CIS as it's a globally recognized entity that provides us with regulated guidelines. So the customer finds more comfort that these globally recognized entities being used. And it also provides recommendations to many cutting-edge technologies like your operating systems, your cloud service providers, and your Kubernetes, and many more. So as our POC for today is about cloud infrastructure, we'll move into CIS for cloud service providers. So CIS for cloud service providers basically provides us with recommendations on how to securely configure a cloud account. It provides to many cloud platforms like your Microsoft Azure, your Google Cloud Platform, and your AWS, that's your Amazon Web Service. So CIS for AWS, let's move into CIS for AWS. So the recommendations given by CIS for AWS have been divided into 5 sections. That's your identity and access management, storage, logging, monitoring, and the last one being networking. So in identity and access management, CIS recommends you to provide strong password policies, multi-factor authentications. And in your second part, that's your storage, it recommends you to make sure that your data is encrypted and not publicly accessible. In logging and monitoring, CIS recommends you to provide you with alarms and do event tracking and also provide threat intelligence. In the last part, CIS recommends you to on what traffic should be blocked and what should be allowed into your cloud environment. So we'll take a demo into practical attack into consideration. So we are going to take a poorly configured S3 bucket as our scenario here. So firstly, S3 is the simple storage service that's provided by AWS to store data. So data can be stored in the form of files or objects in files in the form of objects. So these objects are stored into your S3 buckets. So these objects can be hosted on any website, and the objects from the website can be stored into the files from the website can be stored as objects into your S3 buckets. So if you poorly configure your S3 bucket, a hacker can gain easy access to this bucket and access all your objects. So let's look at the demo for this. So I'm going to go to our DPalmer's demo website. So what a layman would usually do is he would just go through the website and check for the required information and then close the website and go. But if you think from a hacker's perspective, he'll try to view the page source of it and try to find anything interesting here. So the page source basically provides us with the HTML source code. Over here, I'll try to find if any S3 buckets are found. And bingo, we seem to have found an S3 bucket here. So when I click on this, the logo pops up as your object here. So according to AWS's naming convention, first comes the domain name, then comes your bucket's name, and then is your object's name. So I'll take this bucket's name and see if we can find something interesting. So over here, I'm going to go into the command line interface, and according to AWS CLI, so AWS S3 LS provides us with the objects that are found in your S3 bucket. So over here, we can see that it's not just your logo.png that's found as the object here. There's also another object that's your demo website credentials.csv. So I'll just copy and paste the object name here and remove the logo.png object. And it's seen that one file is getting downloaded here. I'll just open this CSV file and see what's inside. And it's seen that we are getting the password, the access key, secret access key here. This seems to have been the credentials of an IAM user. So it's found out that not just the S3 bucket, but also the objects that are present in your S3 bucket are public here, just because of one poor misconfiguration. So SYS provides us with recommendations for these kind of attacks. So SYS provides us with the recommendation by providing the description, rationale, audit, and remediation. So moving on to the remediation. So SYS wants us to make sure that the block public access is always enabled. So by enabling block public access, your objects as well as your S3 buckets are not public anymore. So you move on to your S3 buckets that public and go to the configuration block public access. And over as seen in our S3 bucket, it was publicly accessible. So we move and enable block public access so it's not public anymore and save the changes. So you might ask, what's the default settings provided by AWS for these kind of cases? So AWS makes sure by default that your block public access is always enabled. But sometimes, as we wanted to show our logo.png, that's our object, so we had to make that object public. But sometimes what developers do is they don't just make the object public, they make the entire S3 bucket public. So all the objects that are present in that S3 bucket in turn becomes public.
So now we saw why it is important for us to make sure your S3 bucket is private. Let's look into a few other cases, such as making sure your S3 bucket does not take any requests from HTTP, or making sure your CloudTrail logs are encrypted with some sort of KMS keys. And then there are around 56 plus cases that has been recommended by SIS, which is very important for you to make sure your cloud infrastructure is as very secure. Now let's look into few more cases. Let's say your RDS instance is public, or your security groups and ports are set open, or your EBS volumes snapshots are made public. These cases are not found in your SIS benchmarks, but are highly recommended to make sure your cloud is secure. This is the reason why we should be going above and beyond SIS standards to make sure your cloud is as secure as possible. Let's look into the Capital One attack and see what exactly happened there. So the Capital One attack, the attacker was an ex-employee of Capital One. They knew that this Capital One website was hosted on an EC2 instance, which had an open port. And the Capital One website itself had a SSRF vulnerability. So this made the attacker gain access to the EC2 metadata service. Now this service allows you to get access to the role that has been attached to your EC2 instance. Now this role can be attached to any other AWS service as well. So in this case, the role was attached to an S3 bucket, which allowed the attacker to get access to the S3 bucket. Even though this bucket was made private, through this role, the attacker could get access to the information which was compromised in an overnight. Let's look into another example where you're making sure your RDS instance and your EC2 instance is only accessible using one VPC network. Let's say that this RDS instance is poorly configured, and let's just say this attacker knows an connection string or the password for this RDS instance. Now, if this RDS instance is poorly configured, the attacker can easily get access to the information or the database present in your RDS instance. Let's look into this exactly how. This attack was actually seen in an Fortune 50 client. I'm going to open my SQL Server Workbench, which allows me to connect to any RDS instance using a connection string. Let's say I am the attacker here, who can be an ex-employee who knows this connection string already. So it asks me to give a host name. I'm just going to copy paste the connection string I already have. This also follows the Amazon naming convention. First being the RDS instance, second the region, and the third being the domain name. I'm going to keep this connection name as demo connection and try to connect to this. It's going to ask me some password. Now, if you haven't changed your password or have kept it as a very predictable one or a default one, it is very easy to get access to your RDS instance. Now, you can see that within seconds or minutes, I'll be able to get into the RDS instance. And voila. You can see there is one database in this RDS instance. Now, if this was a connection string to an multinational company organization, they would have had multiple databases, millions of tables, and a lot of information in each of these tables. Now, I can just click onto this database and see there are a few tables. And I'm just going to try look into one of these tables and see what it has. So this employee table seems to have few of the personal information of employees. I can easily even change the data present here, or I can delete this, or even delete the entire database for an instance with just a click. So you can see, this is how easy it is to make sure your RDS is easily detectable. Now, this all could have been prevented if you had just gone to your RDS instance and make sure your connectivity settings has an additional configurations called as not publicly accessible. Now, if you had turned this on, it wouldn't have been possible for anyone to access this RDS instance. Usually, by default, this is not publicly accessible. Nowadays, due to pandemic, most of the employees tend to work from home and will not be able to access this RDS instance because it is not in your VPC. If you want it to be accessed beyond the VPC network, then it should be publicly accessible. The DevOps engineers just make it publicly accessible to make it their work easy, and which is not recommended basically. So to tackle all of these problems that we face in your cloud infrastructure, we have come up with our own approach to create a powerful monitoring tool that automatically detects the misconfigurations present in your cloud infrastructure. It only focuses on your cloud infrastructure and nothing about the web API or the API security part of it. What we have done is compiled cases that are SIS recommended and the cases that go above and beyond SIS, which we have compiled this to create our monitoring tool that majorly looks into 5 sections, that is IAM, logging, monitoring, storage, and networking. So these sections, and it produces 3 major solutions, one being a summary dashboard, second a detailed report, and the third being a CSV file. So the summary dashboard looks into the statistical details and overall security posture of your cloud. The second, the detailed report will tell you why and how and where exactly it went wrong and pinpoints to the misconfiguration present for you to configure it properly, easily. So the third is a CSV file, which can be easily fed into other tools such as Jira or Jenkins or any other bug tracking tool. So this tool looks into, detects misconfigurations in your AWS services such as S3, EC2, and many other services. It takes Boto3 SDK which used for connecting to your AWS account. And as of now, we are able to scan for 60 plus misconfigurations and report the same. So let's look into our demo on how our tool works. We have tried to make it as easy as possible. All you need to do is configure to your AWS account using AWS configure. It usually asks you to give an access key ID, secret key ID, and other information. I've already fed into it, so I'm just going to click away. It asks you to give a region name and the default output option. So I'm just going to keep it as JSON. Now, all you need to do is run a main Python file, which is in one of this location. I'm just going to copy paste here. It's Python. So you can see that the scan has been initiated. It will take some time to run. By then, we will look into the setup and configurations of our tool.
So to configure, as Maithri said, we have to do AWS configure. So the credentials that have been taken here is the security audit credentials. So the security audit credentials basically means that we are only provided with permissions to scan and check the AWS account. We have no access to the data present in the client's AWS account. So after taking the security audit credentials, we run this on our cloud and provide you with the 3 output results. So as of now, we have 60 cases that have been implemented, and for the future, we want to make sure we add even more such cases that provide us threat intel to such misconfigurations found in our AWS cloud environment. We would also like to span across other cloud platforms like Google Cloud Platform, Microsoft Azure, and many more. So,
Let's see if our tool has run by now. I think it's going to take a little bit more time. In the best interest of time, I actually ran this before our presentation to show you the outcome. All I need to do is so this is how our dashboard looks. It scans and tells you the total number of cases that the tool has run. It mentions the total failed cases that have misconfigurations, the number of cases that passed, and the number of cases that couldn't be scanned, mainly because we don't have enough authorizations to look into the configurations of any service. It also looks into the severity in different sections, that is IAM, storage, logging. It also mentions the total number of resources that were scanned from the AWS. Currently, there were around 315 in our account. And it looks into the IAM users, EC2 instances, or the alarms, VPC, and other 16 other services in total. It also shows a vulnerability trend chart. It gives you an overall security posture view of your cloud infrastructure from each scan to scan. It can take up to last 21 scans can be shown on this thing. Lastly, it also shows a detailed report into where the problem lies. If it's a failed case, it shows the case that has been scanned and the service for it. If this has been a failed case, it also gives you a small notes on where exactly it went wrong and where you should focus your efforts on. So these were just our backup slides for now, just in case it didn't run.
So to summarize our entire presentation today, we first spoke about web application securities for the web apps that are deployed into our cloud environment. We saw how the web apps API and the portals are securely configured using SDLC and Secure Scrum. But we saw how cloud infrastructure security is an often neglected topic and how it has a larger threat surface for exploitation, especially in mid-size and small-size businesses, as more workforce cannot be employed for this reason. We saw that manual evaluation is not practical for such kind of scenarios, hence we need automation. We saw the different industry standards like CIS benchmarks or CSAs that can be used, and we also saw how we have to go above and beyond CIS benchmarks, and we also showed our tool that was taken for AWS as our POC, and we showed you the 3 output files. So thank you, and the floor is now open for questions.
Okay, do we have any questions? Maybe? Come on. Someone has to be first. Charge. No? Are you sure? Are you tired? Are you guys tired? Everybody's silent. Okay, no questions. Yeah, everything was crystal clear. Then, yet again, thank you so much for your presentation.
Thank you.
Okay, so I have a few things to announce. We're gonna have lunch. That's good. But we have one more talk before lunch, as you guys know in the schedule. This should be updated. So, but we have a problem. We need more answers to the wrong answers panel. So you have to help us out. Otherwise, it will be a very short panel. So you have to go and ask your question under the hashtag SecurityFest panel, so that we can sort of compile a list of them and do them on the actual panel. So you use Twitter, use the hashtag security panel, ask your question like, denial of service is always the best thing, why? Or something. And we will come up with the most ridiculous answer ever. It's pretty fun. We will, yeah, this is actually shortened down now. Cool. So the panel will be the last thing that we do, and then we will have the CTF awards and then wrap up the conference. Yeah, and we do have some time now before the next talk, so if you want to grab a coffee or something, you could do that as well. Charge!
solutions to different problems. I also organize a bug bounty meetup in Israel. So it's fun. It's collaborating all the hackers and the security engineers from all different companies have the way to communicate together and find a common target. And this is a very good way of knowledge sharing. And I'm just like since 2002 hacking stuff, building from production plants, vehicles, web, banks, whatever you need to hack, I can hack. I don't do physical. One time I was asked to do physical, it didn't go well. So today we'll talk about package managers. Like package managers are fun, are interesting, but I want to go into old school. Before I want to go into old school, I want to explain about a bit what package managers is. And package managers from Wikipedia, you can see it's a collection of software tools that automate the installing and upgrading software, but as you can see, Wikipedia says it's a consistent matter, and this is what's important over here, because the definition in Wikipedia is always right, or they always tend to be, they want to be right, but sometimes the fact is that it doesn't. So I want to show you if it is really consistent or not in this presentation. So in the old days, I used GetRight. This was a download manager, not a package manager. It downloaded files, and it was very easy to use. It just, like, whatever I wanted to download, it downloaded it to my computer. And then I had different options to shut down, to disconnect from the internet because I was billed by the minute, and different, like, options that in the past, I don't know who now disconnects from the internet. But today, most of the systems you have, like, you want to install, let's say, a Dragons package, you just pip install Dragons, or you do just npm install, and you don't know what's happening behind. The package managers do lots of stuff. They download, they install, they run different types of scripts, and this is why package managers are very easy to use as a developer, but very hard to secure as a security engineer. And this is like if I want to install one package, but when I download a repo from the internet or a repo from my developer source code, I just run pip install dot or npm install or bundle install, and everything happens automatically. It downloads everything that is needed, and I don't really know what's happening over there. But first of all, how does a package look like? So I took a very basic package, and actually I looked in Google, I searched for most useless packages in the world. So I found isNumber, and isNumber is a package that has 250 million downloads per month and 3.9 giga downloads. I don't know what's a giga download, but it has, and GitHub, they say it's, I think they had a mistake, it's billions. And this is the code of the package. It does actually nothing. Like, it just checks if it is a number. But most packages, and if it's a direct dependencies or transitive dependency, use these kind of packages, which are maintained by someone. They are maintained by someone out there. We don't know him, and this is why the OpenSSF created like a project to see how secure is a package. And if you can see, it got a score 4.8. It's not maintained. Nobody touched this package for 5 years now. There's no code review. There's no best practices. There's no branch protection. There is different like pin dependencies and license and binary artifacts there are. But as for if this package is maintained, nobody knows, and it's some random guy out there, and I don't know who maintains this even. But usually, my package, my service will use it. So the question is, if this maintainer or if someone will change this package and just add this 2 lines like spawn hack system, and everybody knows that hack system hacks the system. So if he just changes it, what will happen is my packages will start like packages that rely on it, and other services that rely on it will start getting hacked. And I can show you who can change this package. So first of all, the maintainer. And we saw there was an open source maintainer had colors, and he got mad on someone. I don't remember what happened, and he just like pulled the plug on colors, deleted it. or just upgrade it to something that doesn't happen, and you start seeing builds all over the world starting getting failed just because this one maintainer changed something. Another, we have hackers. If someone hacks into core or C or UA parser JS that happened and had crypto mining, then they can hack. They can if there's no 2FA for this user, they can just hack their password. Usually, you can get the maintainer email and then find it on was this have I been owned, and just like go and get the passwords for them. So now NPM started like enforcing 2FA for popular packages, so it won't happen, but it's still. And I'm giving a lot of examples from NPM, but it happens also on Python repositories and Maven, and it happens everywhere. Just like NPM was in focus this year, and this is why most of the examples are from this. And we have confusion attacks. This is Alex Birsan made this year. I don't know how many people heard about confusion attacks? Okay, about like 1/3. So I will explain a bit. Confusion attacks is when there's two packages, one private and one public. Then the package manager just decides to take the most recent version. So if you have a private package that you're using, let's say Rotem 123, and someone else uploaded a public package named Rotem 123 but with version 9, and my version is 8, the package manager will automatically take the public one and not the private one. And then you can just like upload a package over to the public and steal all the data from private repositories. So he hacked and he did like a lot of noise and a lot of money. So and the question is, why is this happening? It's usually like if I would want to get a specific version of a package, I would want to ask for 1.2.3, like a 1.2.3 package. But then when I want to upgrade the package, it takes them a lot of effort, and developers don't like effort because it takes time. So there's a semantic versioning or other kind of upgrading versioning capabilities. So you can make the software automatic upgrade until what you want. And this tilde that you see here says that every minor version or patch version, that's the 2 and the 1 at the end, gets upgraded automatically if I install now a new package. So if I have a package JSON that has my package with 1.21, and now a maintainer creates a new version 1.2.2, then automatically my package manager will upgrade to this version. And this is not good. So to fix it, and we created like different types of log files, and each package manager has a different kind of log file. NPM has a package JSON log, and pip has a pip. You can have all requirements txt and freeze it, or pip file. And you have in Go, you have Go sum and different areas. But at the end of the day, it has the version that when the developer installed the package, it decided at the same point to download the specific version. Then it does an integrity check and has the hash. So if someone in the future, let's say, will download from a different repository or has a man-in-the-middle attack, then the integrity will be changed and the package manager won't install this file. So we have these log files, and they are very good, and if we use them properly, they can save our nights from getting hacked. I know sometimes it's nights, sometimes it's weeks, depends on the problem. And I want to start talking about what can go wrong in these areas. So can anybody say how many problems they can find here? This is a Docker file. It has a from node, adding the package JSON, running npmi, and then on npm start. Can someone say if he sees a problem? No. So I'll get you the answers. So first of all, when I use Docker file, the latest take the latest Docker file from the repository. So if someone just upgraded a new version, it will just download. Usually I would want it to be tagged to a specific version, or better, tagged to a specific hash. So it will download the specific hash that I checked and verified, and not just the latest thing that happens next time Kubernetes will restart the pod. differently, there's the package JSON. What happened is in this Docker file, before it didn't have the asterisk, so it copied only the package JSON and not the package lock. It means that in the build systems inside everywhere, it won't use the package lock. So it's good because everything will work seamlessly until someone upgrades a bad package and everything will start failing. And at the end, there's a difference between npm I and npm CI. npm CI tells to make sure that the log file is there and is correct. If you run with npm I, if you don't have a package lock, it will install and create a package lock. If you run it with npm CI, if you have a package lock, it will fail. If you don't have a package lock, it will fail. Or if there's a difference between what's in the package JSON and the package lock, it will fail. This is what it's supposed to do. So this is different stuff that we need to put in consideration when creating Docker files. And I was playing and looking at AWS in the past, and I saw that AWS, the default Lambda function, when you create a default Lambda, it doesn't add asterisks and doesn't do npm CI. So I've been talking and they changed it, and now all the Lambdas have a package asterisk, so it also copies the package lock files. They didn't want to put npm CI because they say it's not production and everybody should secure themselves. So we just added a comment at the end to run npm CI -- production. You should also add minus scripts only. I will get to it, but like no scripts. So it will be safe. So first of all, I want you to all to make sure when you go back home that you use log files. Like make sure that everywhere, if it's from Dockers or to npm or pip or Go, never forget the package lock. Use it in all the areas from the developer machine to the CI to the production itself. If you want to use npm CI, and we understand that we need to use npm CI, so this is the correct way. In the developer machine, the developer adds his version, like he says we support Axios 0.21.0, and then when the CI build, it will always install the version 0.21.4 because this is the latest. Then this is what was happened the moment he did npmi. He did full testing. He made sure everything works. He wasn't hacked. The CI build should also not be hacked in the same time. Now, this is a game that I, as a developer, also have a lot of troubles. And I am lazy and I don't want to download the repo to myself, add an npm install or upgrade some version, and then re-upload it. So sometimes I just go to GitHub and change only the package JSON. So in this case, I'm changing the package JSON to 21.1 or 25 or whatever I want. And then when I'm running npm CI, and I put here npm CI 6 because this is in npm 6, it's working good. It says, yeah, you have an invalid log file because you have a log file. It saved me, and I don't have. You change the package JSON, but it expects you to change the package log to be the same, so it will know exactly what to download. So in this case, npm CI 6 failed, but I went and checked npm CI 7, and back in the start of the year, it was also on npm 8, like in the latest edition. And you can see that the same change exactly, but npm 7 continued. It said, yeah, there's an old log file, and it added 2 packages, and it went over and did what I wanted to do. So there was a breaking change, I think for 1.5 years in npm, that made npm CI useless or not really useless, but when there was changes, then there can be a drift, and when developers change the package JSON file, there can be a change, and there will be a change that will install a different, so when I changed to 21.1, it went and it didn't find it in the package JSON, so it went and installed 22. It installed a different version altogether. So this is funny, but also I will continue investigating this, and I found out that the package lock doesn't need to have anything at all. So if I just like minimize the package log file to having nothing, just like brackets, it also worked. So it said, yeah, there's an ancient log file. It's ancient. It doesn't have nothing in it. So let me create it for you, or let me just install everything for you. And this is actually pretty interesting because if you have different audit controls and SBOM, and like SBOM is software bill of materials, so if you have different stuff that audit the package lock, you will see you have nothing over here, but you do have information and the stuff in package JSON. So you will see it, and you won't see it in the code. SBOM will be empty, but in production you will have all these packages and vulnerabilities if possible, and nobody knows about them. So after 1 year and a bit of discussions, the NPM files fixed it. They created a CVE. It got 9.8. I don't agree with it's not that critical, but it's fun to get a critical CVE. So they fixed it. They fixed it in 8.1.3. But still we have other problems floating on. And if you look in it's easy. You can just go to GitHub to the issues and look for different stuff. We have package lock JSON not noticed, not repaired automatically by NPM, or overrides not working correctly. So in the package JSON, you can override packages in inner packages to say you have to have these these versions. So they're not working correctly. It's still in triage, and like one of the things that I want to make you to know about it, that the package managers do stuff and they verify, but don't trust them. They don't really verify properly. Sometimes you always have to verify yourselves with external tools, because they're not built for security. They're built for development, to make sure everything works, but security is not one of the use cases they were built for. A bit of my bug that I had, and last year I did a big research about malicious code analysis. That's how to hack the scanners themselves, like code scanning scanners. And I did it, I presented in DEF CON about it, but then I wanted to continue my research, and I saw if scanners are able to be hacked by different types of attacks I will show you. Also, maybe NPM and maybe other package managers can be hacked in the same way. So let's say we have npm CI -- ignore scripts. And -- ignore scripts, it makes sure that nothing will be run from the package JSON. So if you know in package JSON, you can run post install or pre-install, and when you are adding a dependency, it will run scripts, it will run shell scripts inside your CI. And we want to make sure nothing runs that we didn't want to run. So for example, if I have like an npm token for my private registry, and I'm running npm CI ignore scripts, and then I can unset the npm token and run the scripts I want to run. This way, the script doesn't have access to my secret password to the registry. But npm specifically looks at different configuration files, and it will look up in the user directory, but it will also look in the project directory. So when you are inside the same project directory, it will look in the target if it has a .npmrc, and will load it. And loading it gives you different options. Sometimes it gives you people put the password inside, so a password to the registry over there. But I can override it with whatever I want. So I usually override it with a script that has a remote code execution. So inside my .npmrc, I can unload that script that tells when npm loads, I run a script of my own. This happened in npm 6, and npm 7 they disabled the script, so you can add a git script, so and have like a replacement git binary. And then when you try to clone from a Git repository, it runs this alternative Git client. So you can just like run code. So whenever you have .npm, you can just inject this file, and it will run your code. And the attack scenario is very simple over here. A developer, any developer, let's say we have an organization with 5,000 developers, or I don't know how many, 500, 1,000. We don't trust all of them equally. And the moment he pushes something .npmrc into the repository, the CI executes the code. It starts like have access to the secrets, to the production access, network access, containers, whatever he wants. And this is a way for a developer from getting very specific permissions to have full production access. Full production access. But it happens also in Python. So pip install, usually if you install pip, then it looks for a setup py. Setup py is Python. I just like can import whatever I want. Like it doesn't. It's not like I have to be in the same like way. Add the requirements. Add everything. It's Python code. I just like hack it. I put my OS system. Who am I? Says exit and finish with doing whatever I want inside the pipeline. Same with requirements. Requirements is not Python actually, it's static code analysis, but it has different like flags. So if I put -r etc password, I can inside the requirements it goes and fetches. It tries to fetch a different requirements from etc passwd, and then if I have access to the logs, I can see it. Or I have a SSRF target, I can add a -r SSRF target. It will go and get it from it. We have Ruby bundle install. There's a gem file. The gem file is actually parsed by Ruby. So again, same. I just system. Who am I? Whatever I want. All of the package managers, not all of them. I think Go I couldn't hack, but the other was. But others, it's very easy, and it's because they're designed to be developer friendly. The developers want to configure stuff, so it's very easy to configure. You just have full Python code or full execution code. So package managers at the end will execute code, and you need to understand that when running them inside different environments, code can be executed, so you need to put them into the right areas with no access to sensitive passwords and no access to file systems or network access or whatever. Just make sure, treat them as viruses. Vulnerability scanning. Let's say we have vulnerability scanning inside our systems, and we have npm audit, and we have different types of scanning that we want to make sure that dependencies they don't have any viruses. So let's say I have npm install, and this is npm install, but it does actually npm install does npm audit automatically, but I can also just do npm audit on the packages. And in Pack Resolver version 4.2.0, it has one high severity vulnerability, and then probably the CI should block the installation, and nothing can go, and they need to fix it. But if I alias the package in npm 6, then if I alias it, I do the Pack Resolver alias to the same version, then the npm audit doesn't know how to behave and it just passes. It doesn't tell me one package was skipped or was not verified. It audited all the 20 packages and found 0 vulnerabilities, and the same thing that 1 second ago was vulnerable. So if I as an attacker want to add a vulnerable package to a dependency on mine, I can just like alias it. And if someone uses npm 6, now in the CI, I don't know how many people know here what npm version they're using, but I'm probably like some are using npm 6, some are 7, 8. There's nobody really cares about which npm version they're using because it's not something that people know of. Just like whatever was in the Docker file initially when they installed it. So usually, if you have node 16, it will have npm 6, and I think the new nodes have npm 8. So another way is just like going and asking repository, like this is out of store packages. So if I go to GitHub and ask for a node pack resolver with branch 4.2.0, actually, this is something cool that NPM does. It does go and resolves it and finds out it's a 4.2.0 and resolves the data and knows to find their vulnerabilities. This is some cool things they did. It's pretty nice. But if I change a bit the syntax and I put a dot over there after the .com, so they think it's not from GitHub anymore, and then it's out of store, or I can just host it in whatever server I want, any Git server, and then again it finds 0 vulnerabilities. So it doesn't tell me nothing. I don't have any configuration to tell it if you could not audit it, break the build or tell me about it or do something. I added a request in the RFC to do it. They're still thinking about how to do this, but I would expect someone to have a flag, block the build if you cannot audit, or just tell me about it. Tell me there was one package didn't it was not able to audit it properly. And also, more complex thing is depends on recursive. So if I have my awesome project and I have is number or readable stream, but is number is using a subdependency that isn't auditable because it's out of store dependency, nobody will know about it. So now the question is like, do you know how many packages that are out of the package store and are skipped? And it's like too much work. SBOM also won't parse it. Nobody will know about it until it will get hacked, and then it will be too late. So like, I think you should do your own SBOM vulnerability analysis. Never trust the package manager to do it for you, and that's it. A bit of this is I added it today, actually yesterday, because I saw that yesterday someone, Christian, added. So there's another way to hack dependencies. Last week, you can look for packages that don't have that the maintainer had a domain, an email domain, and the email domain got deprecated or he doesn't own it anymore. So if you have a maintainer that doesn't own the email, so it's just like subdomain takeover, but just like email domain takeover. You just buy the domain from him, from GoDaddy or whatever, and then you can reset the password and get the same permissions of this package manager of this package. And what he did over here, he released inside in GitHub a tool to just enumerate all the packages whatsoever and see who doesn't have a domain associated, and you can just like take over it. We see then there's a tweet and in Twitter they're starting to talk about, yeah, I also created this and I also created this, and people are starting to talk about it, like NPM, and nobody isn't doing nothing about it. And it's not only NPM. I'm taking it as an example, but everybody, if you have a maintainer somewhere, and this is like someone just had the best meme, your next task is to find all applications in your organization that depend on NPM packages that maintainers let their email domain expire. And this is like a nightmare. So I don't think like anybody can do it properly, or it's a big problem, and it's something that we need to be on it and understand how to do it and start like owning our packages. A quick recap. Package managers install what they want. They execute unwanted scripts. They have audit checks that are easily bypassed, and random people maintain packages. That's like you trust the world for your all your services. Just like I fully trust everybody. Nobody will do no harm. I cannot like. It's a problem because I rely them, and I use also package managers all the time, but I can't live without them. I know they are bad, and we are working on making the world better. If you do have package managers, so first of all, make sure that you verify that there are log files. you manage the SBOM, the software bill of materials, so you can know when there's in the future, like tomorrow, there will be a new package. I don't know, dinosaurs got hacked. You can make sure in 5 seconds, 1 minute, just go to your SBOM, see, do I have dinosaurs package? If yes, go and check what is vulnerable. Go see which service is vulnerable, and if someone hacked into you already, or you need to just upgrade it. So you just like monitor everything all the time, but make sure, because if not, it's just like you have to spend your night and starting to get all the SBOM data. Don't give them permissions. Run them in containers, run them with minimum permissions, isolate them, like treat them as they should be. They don't need any access to nothing except download the package and then give someone else to install it. Audit checks. If you have audit checks, the same. Just run external audit checks. Don't use the built-in audit checks that they have. Take account of the specification file and the log file. The log file, they have different purposes and different life cycles. So inside the developer machine, usually the specification file is what counts. Inside the CI, you want to make sure that the log file, but then the log file is also the most like the correct source of truth will be inside the container. Inside the build itself, you can see like in Node, you have Node models. This is what was really installed. Monitor it. You can know the package lock because you want to shift left and do all the stuff for the developers to fix. But at the end, in the container itself will be the source of truth. And verify out-of-store packages. This is or just like know which out-of-store packages you have, and make sure that nothing changes over there. Lock them, lock the hashes. I think that's it. I don't know how much time I have.
You have plenty of time. So
Yeah?
questions?
So I have 10 questions.
Good.
Oh.
I got 2 questions.
Yep.
Yeah.
So you mentioned the NPM to take over all the domains, right? Earlier in your talk you mentioned that NPM also embedded 2FA now. So how does that work?
Yeah, so the question was also the NPM had the domain hacks, but also NPM had the 2FA. So NPM they didn't force 2FA yet. They are trying to roll out 2FA. They rolled it out to the high maintaining packages, but also 2FA is, it's depends on how 2FA is done, because if 2FA is still done with the email itself, then it's not really 2FA. So it's just like it works like that. Yeah, but if yeah, just buy all the domains.
I got another question. You mentioned that you played around with Go and wasn't that successful. Did you play around with Homebrew?
With Brew, no, actually I didn't, because Brew is like what I specialize in, and what my research is stuff in the CI/CD, and Brew isn't is more like in the start of the developer line. Maybe one day I'll get over there, but it's not like in my focus that I'm looking at.
Cool, thanks.
Good.
Yes. What about what?
NuGets.
NuGets.
Microsoft.
Yeah, I didn't play with Microsoft yet. It's in my plan, but like I'm looking mainly. I think NPM is the most common package manager. Then pip. We have some customers with Ruby, so I looked at that. I don't know. I don't like .NET. But
Good. You got it in there. So npm install questions? No?
yeah, here.
Dash force?
Yeah, we have a question.
Yep, go ahead.
Can I?
Private repository. Can you run a private repository?
Yeah, you can. Like lots of companies use like a private repository, like JFrog or something else. The thing is, usually the private repository will be proxied and mirrored by the public repository. Actually, a good recommendation of mine and I didn't see anybody doing it yet. But if you can proxy the public repository, but give it a delay of 2 weeks, then let the shit hit the fan for all the world, and you will be getting the new updates only after 2 weeks, and that way you can get protected. If everybody will do it, then we will have after 2 weeks, but that's a bit different game. Yes? You want to...
So can you force NPM to only use
Yeah,
your source of truth?
I think you can to use only your private, but then your private is mirrored to the public. So unless you're on an on-prem closed solution, you will always need a way to get new data. Like your developers will hate you if you don't get the updated versions all the time.
Makes sense.
Yeah, I think 2 weeks is a good solution. Just if I inject a .npmrc and tell it to go to public. So yeah, there's a bypass. You just need to make sure that nobody adds a .npmrc before you run it. Because if you have a .npmrc, then someone can just change the registry to the public one back. Or block the whole network to public and get everybody work through Citrix and like in the old days. Again, the developers will hate you.
Anyone else? Okay. Then I guess thank you very much for this very interesting talk.
Thank you. Great. If you have any questions afterwards, I'm available here. And if you mind, I will take a selfie with all of you, just for fun.
Charge! Yay!
Great. Thanks.
Good. So we're going to do the human Tetris again, because we want food, no? Everyone is hungry? Pretty early, yeah. So that's why I'm... Now I get something here. It's like, I can see. Are we ready for lunch? Yeah, right. We're a lot of people. So we're going to do this like lunch is served in 20 minutes roughly. We're going to do it the same way we did yesterday lunch. So we will open those doors. You have to stand in a line. Don't kill each other. It worked out very good yesterday. No one died that I'm aware of. And that's all that matters. So if you bury them deep enough, I think it will be safe. So you queue up here. You go through the left. There will be food, right? How many lines of food is there? 3, right? So there is 2 for people that are eating meat, and there is 1 for those who does not eat meat.
Everyone's been fed and watered. Taco Friday. Just before we start, I have a quick announcement. We found a wallet. So we're putting that in the prize for pool for the CTF. Now it belongs to a Matthias Holmqvist. So if he's around, please come and find it in the streaming booth. And if you know him, let him know. If he hasn't shown up, we'll hand it to the staff here at the hotel. So, yeah. Okay. Without further ado, please join me in welcoming our next speaker, Mr. Dan Nagle.
Test. We good? Good afternoon, everybody. My name is Dan Nagle, and this is Hacking Network APIs. Before I dive into it, I want to just touch a little bit about the logistics, about how this is going to work. So it is a series of 3 demos, part 1, part 2, and part 3. I did not know how much time I would have, so I brought 3 demos, and the organizers were kind enough to say, do all 3 of them. So that's great. So what we'll do, since it'll be kind of long, is I'm going to do part 1, part 2. We'll do a quick break. I'll set up part 3, and then we'll do part 3. This also helps me because one of my power adapters got TSA'd. If you've ever flown in America, you'll know what that means, and your response will be, say no more. So it did not survive the trip over here, but that's okay. Let's get started. So about me, I'm a senior cyber engineer doing VR research, and I'm also a software engineer. I've written a lot of software, desktop apps, mobile apps, embedded servers, firmware, electrical engineering. But my claim to fame that I'll be talking about today is I'm the author and inventor of Packet Sender, which you'll see on full display for these demos. It's available everywhere. I think as of last month, it has passed 1 million downloads, and it's currently tracking on about 400 downloads a day. It's being taught in universities. I know at least one in France has a part of their coursework. In New York, if you were to take a class, you'll have a 3-part lab series on Packet Sender. And I get lots of hits for senior design students. You'll see plenty of that in this presentation. I'm also the author of this book, which you should not buy because it is at least 8 years out of date. It's about web game development, and I can't not think of any technology that moves faster than gaming and web, and I wrote a book. So if you want to see how that state of development was 8 years ago, you can pick this up. There is one part that is still relevant. Let me find it. It's about 15 pages where I talk about installers, how to build an installer on Windows and Mac. That actually has not changed much in the past 10 years. So that is still relevant. I believe on Apple, you have to notarize your app now. So that's the only difference. So if you want to flip through it, I brought a copy so you don't have to buy one. I'm also the author of 2 network patents. Does Sweden care about US patents? I don't know. Perhaps they do, but anyway, we can talk about that. But I want to get into the demo. So, are we all familiar with Wireshark? Yes, most people. Absolutely amazing packet sniffing tool. If you ever get into network development, troubleshooting, you'll become very familiar with this tool, and you'll absolutely love that it's available. In tandem with Wireshark is my app, Packet Sender, for packet sending and receiving. The idea behind it is you launch Packet Sender right here on one window, Wireshark on the other. Between the 2 of them, you can troubleshoot, reverse engineer just about any network protocol, and you'll see plenty of that. I'm going to do just a quick run through before moving on, because it's a whole lot easier to understand if you just see it. So here it is. It launches immediately. That's thanks to C++, not Electron desktop apps that was talked about the other day. So it launches very fast. Up at the top, you get your IP addresses, your current IP addresses. Sometimes you just want to know your IP address. And I don't know why, but operating systems like to bury that somewhere. But here you look at the top. If you want to know more, the subnets, that's all right here. And then you set up your packet name, the ASCII, any kind of ASCII notation. It supports slash codes, /r/n/t. If you've done software development, you'll know what that means. Control, line feed, tab, and it gets translated to hex right here. So between the two of these, you can define just about any kind of packet system that you care about. So any kind of format. This line is actually very, very forgiving. So I know a lot of places they use colons to separate the hex. So you can put colons right there. You can put X's. You can put spaces. I know some tools use H's to designate hex, and it'll just fix it. You can even have just no delimiter at all, and it'll fix it. So you should be able to copy and paste from just about anything and put it in. And when all else fails, load your file directly and toss it in, and you're good to go. Once you have your data, you set your IP address. I have one set up right here. Your port, resend. This supports down to tenths of a millisecond, and TCP, UDP, and HTTP protocols, which I will not get into today, but familiar with the tool Postman. So this has kind of its own little mini Postman system going on. And down at the bottom, it can listen to any number of ports that you want. So UDP, TCP, SSL, those are ports it's listening to. IPv4, IPv6. We'll just do a quick test. So send. If you're familiar with the DNS lookup system, then this packet might make sense to you. Turn on persistent TCP so you can hold a connection. And I just did an FTP connection into Debian, sent it, and that's the response from the FTP Debian server. Here's another good one. We'll move down to an SSL connection. So SMTP for Gmail. There it is. So it did an encrypted connection, handled the negotiation, and it sent back the response. So you can do encrypted testing if you want with those sockets. This collapses if you want. When it does an SSL connection, it gives you information about the SSL itself. So it made the negotiation and it encrypted with found the cert GTS, that's Google cert. I'm not authenticated with anybody because it's a self-signed. And AES 256 was the encryption scheme. So another useful thing about this, when you're developing sockets, encrypted sockets, your SSL may not be ready yet, or there's probably bugs that you're trying to figure out. So we'll do a quick test of that with cert mismatch. There we go, right here. So I made a connection, and it did not match the host with this certificate. So there's a certificate error, and it tells you what it is. But what it does, it just connects anyway. So you can transfer your data and then figure out later why it's not working for you. As with every nice tool, there's Easter eggs. So I'll show you right here. If you want to admire my two puppies, hold control, PUP. That shipped for free with every version of Packet Center, just for you. And of course, there is the command line interface. Just about everything you can do over here, you can do over here. One in particular that might be of interest to you is this right here. This is the intense UDP traffic generator tool. So you can just flood your network, and you get a few knobs about how you want to flood it. I actually got an email about this the other day. Somebody was telling me, it's like, I think someone's DDoSing me with this tool, this traffic generator, and he sent a screenshot of it. And my answer was, well, that's neat. Why would they use that when they could have used the command line, which is faster? And you get more knobs to tweak it. All right, so that's a quick run through of Packet Sender. Screenshots are good. What I have in bold are the things I'm going to cover today. So we just got a brief overview of Packet Sender. We're going to control devices beyond their original apps. The idea being I have an app running on here, and just say it's Windows only. but you're a Linux user. You want to reverse engineer it. There's all kinds of valid reasons you want to reverse engineer. So we're going to reverse engineer it. For automation, you saw the command line utility. Just by anything you can do in the command line, you can script. And then the malware analysis. So let's get this going. Before I have to go further, does everybody know what the difference between UDP and TCP? I see half the nods. The way you remember is TCP, point-to-point, guaranteed delivery, error correction. UDP, send and forget. Now there's all kinds of reasons why you would want to use UDP versus TCP. You'll get to see both in action. So, but just keep that in mind as we go through this. All right, PyPlayer. I have PyPlayer running on my Raspberry Pi right here. It is open source. I wrote it specifically to be reverse engineered during live demonstrations. I didn't want to hack. I mean, we can call it hack. I don't want to reverse engineer or hack someone else's tool, live on stage. So I made my own tool just to hack it on stage, and it's right there on PyPlayer. It has the web server. Actually, it's not a web server. It's a control server, TCP raw server, built straight sockets. It has a desktop app, and there is a web app if you're interested in using it to make some kind of music player of your own. It's not a very good music player, but it's great for live demos. The Raspberry Pi 400, it's actually fairly new. Has everybody seen one of these? It's very new. I think it may be like 6 months old, but this is a self-contained Raspberry Pi 4. So it used to be you would get a box and you'd assemble it. You would have to glue the fan on it. But if you're lazy like me and you're just like, well, here's an extra $20, just do it all for me, you can order these guys, and it's so convenient. I just want to make clear that this. It didn't look like one, but it actually is a Raspberry Pi. All right, let's do this. Here's my setup, Pi, switch, display. We're good. Okay. This is the PyPlayer app. Can you see that there's 4 buttons up there? It's hard to see. There's actually 4 buttons. I didn't realize it was so dark. But at the top, it's going to find the Raspberry Pi. So I just found it, and the other buttons become enabled. Play, next, and stop. So I hit play, the command came in, and now my display is playing music. Now I'll play the next song. So with the next button, hit next, here we go. There it goes, and stop, obviously. So I want to reverse engineer this app. So I need to figure out what those 4 buttons do. I need to figure out how it finds the Raspberry Pi. I need to find out how the play button works. I need to find out how the next button works and the stop button. So that is my goal for this demonstration. And if you remember our discussion that I basically skipped, since you're all experts, about the difference between UDP and TCP, I want you to think about what each button could be. So to get started, we launch good old Wireshark. So I know at least, I think it was about 50% nodded yes, but for those who are shy and didn't say yes, it's okay. You're learning. Wireshark picks up packets that are listening onto the wire. And what I want to do is look here and see that I have actually, let me disconnect from Wi-Fi. There we go. Whenever I do network troubleshooting, I highly advise you go into your settings and just disable the network adapters you do not care about. It'll save you a lot of hassle then on. I've seen so many weirdness, especially with VMware. If y'all use VMware, what it'll do, VMware loves to pick up a random IP address that conflicts with other things in your network. Also, Docker is really bad about doing that. Docker is extremely common. So I think it defaults to 172.12 or something, which is extremely common for local networks. So just go in there, disable all of them except the one that you want. It'll save you a lot of troubleshooting later. So I'm going to listen on, let me restart since I confused it. There we go. There is my Ethernet. And I'm going to listen for UDP or TCP traffic on Ethernet. There we go. Traffic is happening. Restart. I'm going to find the Raspberry Pi. Is it going to be UDP or TCP? Which do you think it is? UDP, we'll see. And you are correct. We have UDP. It can't be a TCP because TCP is guaranteed delivery and has no idea where it is. So that's one way to think about it. And let's look at the address. So it's sent to 255.255.255. What's special about that address? It's a broadcast, that's right. So the way it works, hit the button, it sent a packet to the switch and it relayed it to everybody, and the Raspberry Pi replied back, and that's how it found it. Now what did it do after that? We can look at the response, and there it is. Server address, its own address. So that's how it found the Raspberry Pi. That's what I need to replicate. So let's launch Packet Sender. Two five five, 255. What port? Port 15,000. 15,000. And it did fine. That was the response. What did it send? It sent find units. All right, this should work. Then send port cannot be blank. Too many zeros. There it is. So I reverse engineered that button. Now I need to reverse engineer the other buttons. So hit play. There it is. Next. Stop. Now, I want to side note. You notice when I hit play, there's like a pause going on. Or sometimes at the end I hit stop, there's a pause going on. There's two reasons for that have nothing to do with the network. First of all, it is a Raspberry Pi, and it's reading off of a very slow SD card. Also, there are serious inefficiencies in my Pi player code that I did not bother to fix. Now, we have been doing lots of asking if there are any questions. I'm just going to seed some questions throughout that you can ask me. You can ask me, why is your code slow? So that's something you can ask about for Pi player. Because I would love to deep dive into optimizations for code. All right, so we played, we next, and we stopped. Let's see what those commands are. I forgot to ask, is it TCP or UDP? It's TCP. Let's find it. So TCP, we found one. There it is. Play. That's the command. And it's sent to port 15,000. So I'm going to save this. 0, find, Pi. So let's save this guy. I stuck a 0, so it'll sort up at the front. Now we'll do play here. That's my play command, and it sent a unicast to my Raspberry Pi 0.169, and it is TCP. Save that. And let's find the next one. There it is. Next. The next command is next. How incredibly original I am. Save that guy. And now, let's see what stop is. There it is. Stop is stop. Excellent. Stop. I typoed. Just to be different, I'm going to use the DNS here right here, just to show you that you can do that. I have a DNS entry called Raspberry Pi Audio. You can follow my mouse down to the bottom of the screen. I'm going to tab over, and that's the it resolved that DNS entry. So I can save that. Packet Center also supports IPv6. If you want to get that going, you can click this, and it'll go into IPv6 mode. And I have an IPv6 DNS entry for that. And there it is down there. I'm not going to use that because my PyPire code does not support IPv6. But it's in there if you want. While I'm here, one other neat thing that you can do is that might be really helpful in your testing is macros. So Packet Center support, first of all, before I get ahead of myself, let me save this. Oh, I did save it. So if you want to send a unique string, you can do bracket macros. And I want to send the time. And then I'm going to just send that to, I don't want to confuse my Raspberry Pi, so I'll just send it to myself. Do send. UDP. See, there we go. So like I sent a big unique string and then I sent the current time. So there's about 5 or 6 macros in there, and the idea behind that is you want to test something. So you might have a series of tests where you might just want to send this like every half second, and then it just goes on and on and on. And you can see in the logs of whatever device you're testing against when it fails. So you know the string, you know the timestamp. You can look at the first one and the last one and compare the two, and that's when your device failed, and you can go figure out what's going on. All right, so let's stop this and actually hit the play button. There it is. So play, and that was the response. I actually don't need persistent TCP. Next. And stop. Oh, there it is. All right, so I did it. Reverse engineered. So I can take these and I can, export them, go to some other device that uses, like on a Mac or Linux, that maybe this app does not run on. Before I go further, have you ever been taking a class? The one that comes to mind to me that is famous for this is like math class, such as calculus, where the professor goes up there and teaches you how to find the derivative. They'll go up on the board and just do this massive algebraic equation and spend 40 minutes to find the derivative. And then at the end of the class, they'll say, oh, by the way, there's an easier way to do this. It's the power rule. Exponent times coefficient minus 1 or something like that. There's an easier way to do what I just did. But you need to know the hard way before I show you the easy way. So I'm going to do this again, and it's going to be a whole lot easier. So I actually don't need all of this. So I'm going to clear these out, and we're going to reverse engineer this again, and the easy way. So capturing in Wireshark is all well and good, so you can get and copy and paste over. But what's easier than capturing in Wireshark is just having the app tell me its command. So we're going to do it that way. All I really needed to know is the port that it's running on and the protocol. So we know that it's running on port 15,000. So I'm going to set Packet Center to listen on port 15,000. For both of these. So Packet Center can listen on any number of ports that you want. So I'm interested in 15,000, but if you want to listen to more, you can just put it right here, just comma separate it, and 9,000. And the same with the SSL server. So there we go. No, I do not have it two ranges. That would be useful. I completely agree. But you can just, that's way too many numbers. So you can just keep right on going, you know, as far as many times you can type, but it does not do ranges. That would be nice. I agree. Go to the GitHub, click on feature request, and file it. And then maybe a couple months from now, it might do ranges. All right, so I want to send a reply. So I got it set up right here, ready to go. So my address is 0.99, and I already have it ready to go. And I'm going to hit OK. There we go. See, I'm listening to all kinds of stuff. See, this is listening to 5 stuff right now. And anyway, hopefully 15,000 got buried in there somewhere. And restart Pi player. And I need to disconnect my Raspberry Pi. See, I got it all nice and color-coded. For you AV enthusiasts, I worked in the AV industry for like 7 or 8 years. So red means audio, yellow means video. There we go. I tricked it. I told it my address was 0.99. Now he's talking to 0.99. That's where he thinks the Raspberry Pi is. So let's clear out this log right here. And just do, I don't need persistent. And then I hit play, next, stop. It just told me his commands. That's a whole lot easier. And now I just need to save these off. So save, play, save, next, save, stop. I'm not quite done yet because it's talking to me instead of the Raspberry Pi, but we know where the Raspberry Pi is already. So 169. Oops, I need to copy that. There we go. There we go. Now I need the port. Just copy and paste, copy and paste. There we go. We shouldn't need this guy anymore. Reconnect. This takes about 5 or 6 seconds to register. I think it's good now. So let's find the Raspberry Pi. Nope, I don't want to flood. Turn off, respond. So when you send a broadcast with replies, auto reply enabled, it warns you about flooding because you could be sending like to 1,000 things. It comes back and it'll be sending back out again. So a flood warning. So find the Raspberry Pi. Raspberry Pi is not connected. What do I have wrong here? All right. Could not connect. I'm going to remove these ports. My switch turned off. Why is my switch off? Okay. I think my power source is having issues. So what I'm going to do is I'm just going to reboot my switch. These power sources are not super reliable. It can handle about 4 amps. I'm surprised the switch is consuming 4 amps, but I don't know. So this hopefully won't take too long to reboot. While we're at it, I'll show you other tools that you can use with this. So, does anybody use multicast for anything? I see no hands. Multicast is extremely useful. So you're all familiar with broadcast packets, right? That's when you flood the network. Well, not flood the network, but you send it and it just gets routed to absolutely everybody. If you don't want to do that, so notice that PyPlayer used multicast to find it. The modern way to do that is actually with multicast, where you join a stream and then the Raspberry Pi or whatever device you're trying to do will heartbeat back. And then that will get captured. That way you're not just sending packets all over the place willy-nilly. That's the modern way. That's actually how your computer finds your printers using the Bonjour protocol. So my switch is back to life. And there we go. Now I'll hit play. All right, now I want to do one more thing. So you see how this has a nice GUI? I would like a nice GUI. So Packet Sender has built-in paneling tool. So I'm going to generate a panel, and there we go. Yeah. Now I don't want to just beat this drum, but what you could do is you can go in here and just start scripting, additional things. So I could make another button that we'll just call it yay, and I want to send play. Then I want to delay 5 seconds, and then I'm going to send it stop, and so in about 5 seconds, you just send the stop command. There we go. So you can build this this very complex control panel system, and there's lots of very expensive tools that do this, but now you can just launch it this way. So anyway, that's all well and good, but I know you want to get to the malware demo. How am I doing? I'm doing pretty good on time. Let's keep at it. So there's malware on this Raspberry Pi. I don't think I have to explain what malware is. I have a slide just in case. But I do this presentation for university students, and what I want to stress to them is that malware is basically anything that's bad on your computer. So you know how it is. You get a complaint, and someone says there's a virus on my computer, and then the pedantic sysadmin comes in and is like, oh, that's not a virus, that's a worm. And the guy's like, I don't care, just get rid of it. I mean, so I want to teach my students, and I want to teach the general user to just say malware, and then they're correct, because just about everything is a subset of malware. There's malware on my computer. It's like, oh, okay, you just save that conversation. Because they really don't care what it is. They just want it gone. And to be fair to them, I don't blame them. It's like they're not paid to know those differences. They're paid to just not click on things, bad things. So that's the only thing I want to talk about. So you can do that to your users. Just delete all mentions of virus, worm, Trojan, blah, blah, and just replace with malware, and we can simplify the language. So here's the setup. I don't need this display, which is good because I just saved myself an amp and a half. And all I need is my Raspberry Pi. The switch is still on, so let's do this. Oh yes, this is fake malware. I did not write malware and upload it to GitHub, so don't report me or anything. The source code is inside PyPlayer, you can look at it and laugh about how dumb it is. But this is just purely simulation. All right, let's look at it. Let's get this going. To start with, I'm just going to do a free run capture of my Ethernet. And I have all my other adapters disabled except Ethernet. So this, and it's an isolated network. And let's see what happens. There we go, I already got something interesting. My Raspberry Pi is ARPing for 192.168.0.1. The ARP protocol is how it finds the location of other devices so it can get the communications going. Why does it want to know 0.1? That's normally my gateway. It can't find it because it's an isolated network. Why would it want my gateway? Yes, talk to the internet. Why does it want to talk to the internet? Well, usually that's okay, but in my case, I can promise you this is not okay. So what do? I'm going to give him that address. So I'm going to network, and I know you can do this in PowerShell, but I'm intentionally showing you this method because one, I'm a Linux guy. I don't know the magic PowerShell. It's like netsh. And plus, I want you to know this method in case you want to do it yourselves and you're not a PowerShell expert. So one thing I've noticed is not common knowledge is that your Ethernet cables, actually every network adapter can have multiple IP addresses. I don't know why that's just not common. Like they get the idea like one device, one IP address, but you can add as many IP addresses as you want. I think the technical term is alias address. So I'm going to add myself another address. I don't know why Windows bears this under like 5 advanced menus, but there we go. Okay, and you can see here it's up at the top. It got listed right there, so it's active now. Let's run it again. So it should be able to find that IP address and continue on to the next step. There we go, I got something. It's probably a little dark and hard to see, but he found the gateway, and I was telling the gateway, it's like, I want to connect to this random IP address out on the internet. It's actually not random, that's my web server. I'm not going to point at some other guy's service. But he's trying to talk out to the internet to that IP address, and he can't get there because it's an isolated network. So to fix this, I'm going to, once again, give myself an IP address. This address to be specific. So back to Ethernet. Advanced. And I can't remember. There it is. Add. This one is 138. 197. Dot. 192.94. No, that's 84. Let me double check it. 138, 197, 192, 84. There we go. Add. There we go. And there, it appeared right here. All right, it's active. Restart. So now he should be able to find that address. We continue on chasing this malware, see what it's trying to do. All right, he found it. He tried to connect, and it broke because there's nothing there. So when the way this would manifest in your browser, or if you try to connect something, it would say like connection refused. because he found the IP address, but the connection was refused. I know you've seen that error page in your browser at times. That's how that manifests. So what is he trying to connect to? He is trying to connect to 5123. So how do I continue on? Well, I'm going to have packet sender listen to 5123 and see what's happening. So TCP server 5123. And we should be good to go. I'm going to turn on persistent TCP connections. Now we wait for the capture. Boom! There it is. I caught it. Turn on. What is this? Copy to clipboard. Let's blow it up a little bigger here for you. So imagine half of you recognize what this is already. So this is an Nmap scan. What did it find out? Well, it ran on May 29th, so it was several days ago when I was, checking this demo is okay. And then it was found I had SSH open. I'm running on an Apple computer and all kinds of interesting stuff. So what's going on is on my home network, this IoT device, it ran an Nmap scan, it captured it, and then it tried to send the report back up to the mothership to await further instructions. What those instructions are, I don't really know. So what the next step would be is for me to take this and then send it up there myself, capture the response, and just continue chasing down this trail, which I won't bother to do. Just so you know, my servers actually does not have that port open, so you would get connection fused. This is all simulations. I got to keep saying that. So now, are there any questions about what I've shown? This actually went a lot faster than I anticipated, so instead of breaking, I'm just going to dive directly into part 3, but I can pause right here for questions. Yes. So the question was, can I set up packet sender to respond to messages, I guess, in a more intelligent way? And the answer is yes. It's not super intelligent, but there is some there. So the first one, which I showed you earlier, let me close this out. Actually, see this running just nonstop. You saw this already. Send a basic response with macro support. So if you wanted to, you could do, bracket Unix time, and it'll do a macro response. If you want to, you can do smart responses. So enable smart responses, and if the packet equals this, then reply with that. So you can say the notation of it, and then you can enable each one. So you get 5 slots, and you can use macros. If it equals this, reply that. It's not super smart. It would be neat to make it smarter, have some kind of wildcard filter or something like that. But it's a start. So maybe that will do what you need to do. It could be enough. So it supports TCP, UDP, SSL, And just a quick note about SSL. I have to make sure everybody knows this. SSL is the general term for encrypted socket. All versions of SSL are obsolete. They're broken. You should move to TLS. So when I say SSL, I'm actually mean SSL or TLS. It just so happened that all the documentation reference materials still say SSL, and nobody wants to rewrite that stuff. So underneath is actually SSL TLS, and the support for the SSL TLS is whatever your OS supports. Now for Windows, I actually ship OpenSSL with the tool because I can't rely on whatever Windows is doing. And you can see what OpenSSL version it's using if you go to About, and it's written right there. So this is shipped with OpenSSL 1.1 built on April 20th. On Mac, it's whatever library is built in, and on Linux, it's whatever libraries are built in. So whatever on Windows, whatever that version of SSL supports, Packet Center can do. Does that answer your question? Okay. All right, so I can continue on, or we can break for about 15 minutes. No, it's. I thought the panel was after the next. Okay. All right. So we'll break for 15 minutes. We'll come back. What you just said. We'll break for 15 minutes. We'll come back here, and I'll do part 3. Then we'll have a nice long break before the panel discussion.
So we will be back just some minutes after 14:30.
All right. Thank you. Let's do it. Next demo. This is a bonus conference. So I'd like to thank them for giving me a little bit extra time so I can show you this bonus demo. So this talk is about teaching latency versus throughput, which I'm sure most of you already know, but you can also give this a subtitle, How to Make the Sysadmin Angry. So this is going to teach you network latency, network throughput, while also making your sysadmin very mad. And you'll get to see that in a moment. So I don't think I need to define these terms. I think most of you know it, but here it is anyway. Latency is delay between packet send to packet received. It's usually measured in milliseconds. Just a note, it can be measured either way. Sometimes it's measured with going from here to there. Sometimes it's measured going from here to there and back again. So the complete return trip. I've seen it either way. So if you're particular about it, you'll need to ask to define the terms. Throughput is how many bytes can be sent in a certain amount of time, usually bytes per second or bits per second. So you have the unit is second, or on the other one, it's per second. It's a very subtle difference that can confuse students a lot. And I always tell them, when you talk about your network and your network performance, and you want both, because they could tell you, this is a gigabit. It's like, well, that's great. What's the latency? Or you can see, my ping is less than a millisecond. Well, that's great, but what's the throughput? Because you need both in order to be able to say that your network is decent. And quick note before I move on, PowerPoint suggested a ping pong icon right there, and I just kept it, because why not? All right, I liked it. All right, so let's live demo latency through, but I like very few slides and lots of demos. So if you were to add up all the slides that I've been using, it might come out to like 15. So let's get this going. For this, I'll be using a KMax device right here. You can look it up. I won't go into details about it. But basically what it does, you put it in between on your network, and there it is. So you put it in between your network, and it degrades the network in ways that you can control in order to test devices. I do a lot of software development, and I'm very concerned about network performance, about my tools. It's very common that when you have, say, like an app, the app runs like garbage. Why does the app run like garbage? Because the developer is over here sitting at his desk with like an i7 computer with 32 gigs of RAM, and the database is either one hop over, or even better, running at localhost. So of course everything works perfect. Now I don't fault that setup, because after all, the hardware is cheap and developer time is very expensive. So you want that. You want them to have all those tools. But once you ship it and you give it to people, say like me, who live in Alabama and have to go visit relatives out in the boonies, I have one bar, and now the app behaves like trash. This device right here, as well as other network degradation devices, can help you test this. So keep that in mind during your development. So let's get to the demo. Now the goal is to test latency and throughput through the process of network degradation. So I'm going to connect to my Raspberry Pi. So I have a VNC connection into it. This saves me a monitor from stealing juice right here, and it also lets you get to see it nice and easy. So let's get this going. I'm going to launch a couple of terminal windows. This is just running stock Raspbian OS. Actually, I think they renamed it to Raspberry Pi OS, but it's just running stock. And what I'm going to do is I'm going to launch a Python web server. A little technique: if you ever want to transfer a a file from one computer to another on your LAN, that is actually surprisingly difficult to do. I know there's things like nearby share that Windows does from Windows to Windows, but if you want to do cross-platform from, say, Linux to Windows or Linux to Mac, that's actually really difficult to set up. But most things now have Python installed, so you can just launch a quick Python server in the directory that you want. Let me check. There it is. Python. There it is. And now you have a nice, easy, simple file transfer, download. So let me launch the other one. There we go. So that's 1, and that's 2. So it's an easy way to just transfer files. Just launch a quick Python web server. Now I'm going to take this, and we'll see the throughput. I'm going to curl. There we go. It's run a bit slow at first because it's caching, but you can see here it's downloading about 40 megs. The next time around, I'll probably say 90 because it's pulling it off the SD card, which is kind of slow. But anyway, I have really good throughput. Now the other thing I want to check is latency. So let me ping a Raspberry video, and I have less than a millisecond. So that's excellent. I have really good latency, well, very low latency, and I have really good throughput. So is that better? All right, yeah. So I have really good throughput, really good latency. Now the next thing I want to do is trash the network so we can get a good test. So to do that, I'm going to go to the KMax device. Now, I'm not going to just load in the scenario. Like before, I'm showing you the steps in case you want to do something like this on your own. You can see here I have data transferring right here and right here. So I'm going to go to the default band. And let's kick off the download again. There. See, it's cached, so now it's topping out. And we can see the spike right here. So the traffic's happening this way. So we're going to add a classifier, a filter, IP port, and I am pulling that from port 8001. So source port 8001, and this one does support ranges if you want to do something like that. TCP. So pulling from 8001, TCP, apply, close. And I'm going to send this to flow 1. Start again, double check. There it is. So I pulled off that slice and sent it to this flow. So now I can do all kinds of interesting stuff to it. If you're curious where all these other spikes are coming from, it is my VNC connection itself. It's representing that. So we are going to rate limit. Enable 100K. There we go. Close. Now this should behave very badly. There we go. It's like 16 days, 10 days, 8 days. I think it eventually settles down to around 3 days, 5 days when I did this before. So that is horrible. That is basically unusable beyond anything except maybe browsing text or telnet services or whatever. But here's the here's the really wonky part of this test. I'm going to do curl. I'm going to do this number 2, and then I'll make it bigger again. Let's try. My null command got screwed up. Curl. There it goes. I'm going to close this out and just open up a new one. So you make it, expand it, then I can make it bigger. There it goes. So this is going to finish in about 30 seconds, while this one, it looks like it's hitting about 88 hours. Now, here's the part that will make the sysadmin pull his hair out. Because this is the same file coming from the same server over the same network with vastly different results. Can you imagine trying to troubleshoot that? So this user over here is like, this download is taking absolutely forever. This person sitting right next to him, it works just fine. So it is throughput versus pissing off the sysadmin. Now, I want to ask you, like, how would you troubleshoot this? Nobody? You just change careers? What? So, like, I'll go ahead and tell you what you would do is, it's the standard troubleshooting tool, is you would eliminate hops. Just start eliminating hops till eventually this computer is plugged directly into here, and then it would start working, and then you would work your way back. So anyway, but that would be a long, arduous process of getting on the terminal and looking at the router and all that kind of stuff when the problem exists outside the router completely. So anyway, fun stuff. Now, to drive the point home of latency versus throughput, I like to do this. Raspberry Pi video and show that ping is perfect, because that would probably be the first test that will be shown. So, excellent latency, terrible throughput. Now let's look at the reverse. Close that out. Now we've got 2 big screens. I'll leave it here. So I don't need my web servers anymore. Instead, I'll launch VLC. For the latency test. Now, I'm going to, oh, someone asked me earlier, I want to be clear, I think there was confusion, but Packet Center actually runs on Windows, Mac, and Linux, and Raspberry Pi. It runs on all that kind of stuff. I don't know if that, I mentioned something about being Windows only. That was the Pi Player app. But Packet Center runs on everything. And for things that it does not run on, you can obviously download the source code and compile it. So I just wanted to make that clear. For Raspberry Pi itself, it actually runs on Raspberry Pi, but you have to compile the source code. I did not build it for ARM processors. All right, so I've got 2 VLCs, and we're going to do a latency test by launching my own VLC. And here is what I'm going to send. Let me do open reset. So I'm going to send this clock video to both sides. It's just a clock that counts to 1 minute for 20 minutes. So open network stream, and no, not network stream. We want to stream this video, that guy. Now I'm showing you the steps because maybe you want to set up your own ad hoc streaming server. This is how you could do it. Stream that file, yes. And I know Dan from yesterday is a fan of RTSP, but I'm going to use RTP because I want to stay purely UDP. See, the RTSP you can do UDP, it does UDP also if you want, but there's like a TCP connection at first, and then it sends out UDP. This is going to be pure UDP. So I'm going to add that. I'm to port 50,000 to 5004. This is going to be Raspberry video. Is the address. And I'm going to do another one. Raspberry video to the other port that I set up. Next. Next. If you want to do it all on the command line, you could do something like that. Hit stream. I must have did something wrong. Stream. Add this file. Stream. Next. RTP. Raspberry video. Next. RTP, Raspberry video, 50,005. Next, next, stream. It is not picking up the video. Open, here's 50,000, here's 5,000. There's that one. Open. Open network stream, 50,004. There it goes. I don't know why. VLC has all kinds of quirks. Like if you let it sit there long enough, it just loses its brain for some reason. I don't know why. But anyway, we got it. Let's make it a little bigger. So you can see that these are in sync. They're playing the same video, which is what we want. Now, we're going to learn latency by making the sysadmin angry again. So watch what we do. I'm going to mess with the one on the left. So I got to make another classifier. I'm headed this direction. Before I was pulling from the Raspberry, now I'm pushing to the Raspberry Pi. So I have to go on the left. So enable the classifier. Add new filter, and I am sending it, enable, I'm sending it to 5004 with UDP. Apply, and I'm going to do another flow 2. There it goes. So it dropped down here. It's showing me the traffic right here, and I'm going to add a delay. 5 seconds. There it goes. 5-second delay. So once again, we have same server, same destination, same server, sending the same data to the same hub. Two things running side by side with vastly different results. And if you're trying to troubleshoot this, you would have all kinds of issues. Like I said before, you would troubleshoot it the same way before is you would do all kinds of configs tests and it wouldn't work. And then eventually you start decreasing your hops till you actually get to right here in order to figure out what's going on. Now, if you've had this playing at home, it'd be intolerable. Now, if you had just one screen, it'd probably be fine. Like, you start up Netflix, there's a 5-second delay, then you get all your data, no big deal. But I want you to think about a video stream with a channel of audio and video. So it's very common when you're transcoding audio and video that you will separate audio and the video, send them on 2 different channels, then merge the 2 later into one stream. What would happen if one was audio and one was video? It'd be intolerable. Does anybody know what the tolerance actually is for audio and video difference? Like, how much can the human perceive? Any guesses? 100 milliseconds? 10? It's actually around 20 to 50. Like, that's about all you can get. Then the human can perceive the difference. They wouldn't know whether it's leading or lagging, but they'll know that something is wrong. And I have it at 5 seconds. So if I was to do ping, it would work. But finally, what's the throughput of that video versus the other video? If I was to measure the throughput, what would I get between the 2? They'd be the same, exactly. Even though one is completely unusable, you get the same throughput. So that's what I tell the students. Like, same throughput. That's why you need to know the latency. So the previous demonstration had a very good latency but terrible throughput using a download. This one has really good throughput but terrible latency. So that's why you need both when you measure your network performance. Are there any questions about this demonstration?
So if I hypothetically wanted to put this in between an NTP server and a alarm system that would keep the doors open or closed at a certain time, so you would make it where the clock would make it seem like it was not as when it was supposed to close. So I wanted to stay open till 7 p.m. when it was supposed to close at 6 p.m.
That
Would it affect the latency or thing? And would there be a smaller box that I could use? Hypothetically.
I actually don't know. That might work. This is a pretty high-end box, but okay. So what he asked was he wanted to know if he could mess with an NTP service.
No, not the NTP service itself.
But the response.
Getting it to the computer that is operating the door system that tells it on a timer that it's 7 p.m. or 6 p.m. shut the doors, but you're making the time slow.
I got it. Okay, so a command to shut the door, close the garage door at 7 p.m. You capture it with this thing and delay it for X number of time before it reaches the garage door. And that, yes, you can absolutely do that. This thing has a really deep buffer. Now, I'm guessing like that's probably just like a one-off command that might be at most a kilobyte. And you can see here, I have 5 seconds, really bad video, but video nonetheless, 5 seconds. You know, I've dragged this up to 30 seconds. So yeah, it could definitely hold a command for however long you need. No biggie. I mean, this thing's only about 8,000 euros. I mean, what's the big deal? I don't know. You'd have to search around. But yes, theoretically. It may be easier if you were to just capture it and you just build your own echo service. It's not hard to do. So you would have like a little Raspberry Pi that listens for it, capture it, and just kind of hold it in memory yourself to spit back out. Or you can buy one of these. Anyway, yes, absolutely yes. You can do that. It's a good question. Anybody other questions? Ask me more questions. Good question. So the reason why you hit the play button and it grinds for like 10 seconds or well, not 10 seconds, a while before it plays, or hit stop, it grinds, is because I'm doing a system call to Linux to launch a separate app to play it till it runs out. And the way the stop command works, is I do a kill all system call to the name of that to kill it. So the thing is just playing, then it waits for like a pseudo kill to kill it off. It's extremely inefficient way to do it, but I don't care because I'm just trying to do a demonstration. That's why it's slow.
Anyone else? Any more questions? It's the last talk of the day, guys. The last chance to grill Dan. No? Looks like that's it. All right. Thank you so much, Dan.
Thank you so much.
So we've got about, let's see, what time is it? All right, so it's 3 p.m. now. In about 15 minutes, please join me back here for the panel. I hope you guys have been submitting good questions that will get terrible answers, because that's the whole idea. I think a lot of you have, and actually, oh shit, someone put them up behind me. That's great. Yeah, so join me back here in about 15 minutes for the panel, and for the people watching at home, this is the end of Security Fest. I'm waving to the stream. So thank you guys for watching, and we'll see you next year, but you guys stick around. Okay, see you in a bit.